Hey, this session is being recorded. So you have a recording at the end of the session. You should see the red button showing that this session is actually getting recorded. If you do not see that red button, please tell me. I think you see that button, so it should be okay. So we are now talking about what did we cover up until now. Just a quick short recap, just to get everybody on the same page, same picture. When it comes to computing and computing away from a physical location, like our building our own data center, we're talking about resources of three types: the compute resource, the storage resource, and the network resource. Broadly, there are more types. We'll discuss those at appropriate at appropriate stage. But if you these three types, classify them as a resource of some sort that we are basically renting from some cloud provider, and that's what I would generally classify as infrastructure as a service, where you're basically renting this infrastructure from somebody and just outsourcing the task of maintenance. And that maintain part is given to those who know how to do it. For example, if you remember, or maybe you may have seen this thing, Microsoft has sent a data center in the ocean and here. So they have dropped a data center in the ocean to get it cooled. And so this is the Project Natick. And so 50% of us live near the coast. Why doesn't our data? So they have this the cable going down the ocean. And what they have done is submerged this box containing a data center, small one, but valid, complete data center. And they're cooling it through the ocean waters. And that is, if you haven't seen it, I'm going to paste it a link for you. And this is nice. This was expected of large companies to do it this way. I'm opening up Slack chat, pasting a link for you so you can review it later. Slack is taking a little bit of time to open for some reason. Okay, so there we have Slack chat, and in the group, I'm pasting this link. The idea essentially is people who know how to manage infrastructure are doing it. And so we don't have to worry about it. Let them maintain. So these companies like Microsoft and Google and Amazon and others, all these big ones, they let them maintain it. We use it. Our goal is to make sure that we are able to get these resources when we need them, exactly how we need them, and we can release the resource, acquire the resource, make use of it, all of it programmatically, programmatically, programmatically. And to be able to do that in a systematic, automatic fashion is the idea of infrastructure as a resource. It is broadly the idea of cloud computing. Broadly, and if you do it programmatically, where you are able to take a resource, make use of it, relinquish it, and when you release it, don't have to pay for it. All the economic benefits come along. And that's what we broadly discussed. We began with basic machines. We then jumped over our discussion to storage. We saw different types of storage solutions, and then we got our hands dirty, and some of us really had a great time. I mean, I was excited to see the kind of excitement I was seeing on a VPC. Never saw that before. With people in this group, by the way, have drawn beautiful illustrations, are articulating the exact blueprint as to how their VPC would look like, and that was fabulous job. At least two of you did it, which was which was amazing to see the level of interest that you had in actually learning when you know that there is nobody to actually hold your feet to the fire. I mean, there is no pressure. I told you there is. I'm trusting you, right? That's how I began. But in spite of all that, like open-ended way of discussing, this is what I really enjoy. Is I don't put pressure, but I still see everybody, almost everybody, doing it, and that is the beauty. So yes, it was a complex exercise, to start with. And to recap the VPC part, essentially we have, in concept, used all these three elements, one, two, and three, together to construct what we wanted. Is basically two subnets. We call it public. We call this one private. In related video sets, I have it named as border or something, border checkpoint. This one is my application. So whatever you name, these are name. These are basically names. However you want to label them is up to us. So I'm not sure if you have seen those videos or not, but some of you saw those videos where I'm calling this subnet as the border check subnet and calling this subnet as the application subnet, and basically laying out the same idea. So you may have seen it. It is available on the site somewhere here. You may see that. Or I think you know what I'm talking about, so I don't need to go repeat. Having said, the concepts are we are associating this subnet with a route table, this subnet with another route table, and those route tables basically route our traffic. Where should the traffic go? If this is inside the VPC, it should go to the local connection. If it is outside the VPC, somewhere on the internet, which is 0000/0, then it should go through some other method. That method could be a public gateway or a NAT gateway or a NAT device. Either way, the bottom line is you're protecting your application subnet, your private subnet, through a NAT device, through a NAT gateway. And that's the concept. Now, none of this actually involves any redundancy, which is a problem we want to solve. So, what does that boil down to? Let us take an example. Switching over to Amazon. I hope it logs me in. No, it doesn't want to. So we log in. We'll go open up our authentication software and put the token in there to let us in like this. So back here, enter, and now we should be in. So back in Amazon, excuse me. Let us look at that Virginia again one more time. Virginia, and in VPC, like that. And in our VPC, we had this Badal VPC. And if you recall, we have created two subnets. These are public and private. And let us look carefully at one of them. This subnet happens to be sitting in the let's you know what, at this moment I think I should qualify that both these subnets 1 and 2, private and public, as you will see, is all sitting in this availability zone 1E, US East 1E. They both somehow automatically got assigned to the same availability zone, which is nice, but not redundant, right? Which is nice. Nothing wrong in having everything in the same building. So think of availability zone as this AZ. Think of this as a building. That's the best way to think about it. So in Virginia, it's also known as US East 1. In that region, US East 1, there are multiple buildings, like multiple. And when I say multiple, I actually mean more than 5 buildings. I specifically say more than 5 is because they show us only 5. And you will see that when you attempt to create a subnet. The last time we created a subnet, you will recall, we ignored something very conveniently. Click 1 again. And we ignored the availability zone, saying, we don't have a preference. We don't care. Just give me in the Badal VPC, and that's what I want. So I want a private subnet. And by the way, this is the private number 2 and Badal. And last time we said, you know what, we don't care about availability zone, just give us something. And they just gave us something. What did they give us? They gave us US East 1. That was obvious. But then dash E. This E is the availability zone that they gave us, which is, think of it as a building, right? So they show us these availability zones. We call that US East 1 is the region, right? That's the region nomenclature. Then they have this A, B, C, D, and E. These are the 5 availability zones that Amazon wants to show us in this region. If you go look at another region, for example, US West 2, which is Oregon region, they will show us only 3 buildings for some reason. It is because they just have less number of buildings in the Oregon region than they have in the Virginia region. They have more. In Oregon, they have less. So they show us only 3. Now, when you get something in US East 1E, it doesn't mean that your US East 1E as an echo, this E doesn't have the same building connotation as what I might get when I get US East 1E as an echo. This my E is different from your E. That's what it boils down to, right? My ABCDE are different from your ABCDE, from anybody else's ABCDE. They are randomly assigned to an account, to a credit card, saying, you know what, we have these multiple buildings. We're just going to give you 5 of them as availability zones, and they're randomly assigned to you. So your C may be different from my C, and so they're mix and match. You cannot really tell. They're deliberately by design obscured. Now, having understood that part, these availability zones basically give us higher availability. How does that help us? What we essentially will be doing next, or at least attempt to understand what we are trying to get to the point where we have, let's call this the application subnet. We have one. Let's have the IP address range 10.0.10/24. Now here in the public side, we'll call it border check subnet. It's just whatever name we can come up with. No big deal on the naming part, just the name and just the range. Now these happen to be in US East 1E. They gave us this by default because we were not super particular in where do you want to give us this particular subnet. We were not paying careful attention to this idea. We were not selecting that. We're just saying, okay, give me whatever you want, and we just take it. And great. But this time, what I want to do is deliberately select distinctly 2 different buildings, so that if one building goes down for some reason, my other building keeps on working. I hope at least my other building works. And that improves the higher level of availability, HA, when you are consciously selecting your application to be deployed in 2 buildings, or maybe 3, maybe more. So how many buildings do you want to deploy your application in so that it gets you higher availability? That's how you should think about when you're deploying a high availability application. Now, in practice, what does that boil down to? You will do something like this. You will say private number 2. And before you do that, you will actually rename your private as private number 1. Okay. And now I will create a subnet. This will be my private number 2. And it will be in the Badal VPC. And by the way, I know for sure that private number 1 is in the US East 1E. That's where the private 1 belongs. So I would like to choose my private number 2 in 1A. That's just my choice. I can choose any of the characters, A, B, C, D, E, any of these 5 I can choose, except this one is where this belongs. So I would rather choose something else. I choose this. Okay, so we'll do that. We'll go here and say, you know what, I want A. And I will select a CIDR block. 10.0, and this is a convention again. If you recall, the convention for our private 1 was 10.0.10.24. So here I will say 10.0.20/24. And now this will let me create a private subnet with a slightly different range and a distinctly known different availability zone here and here. So 1A. as opposed to 1E. So this is 1A, private number 2. And in fact, to be more clear, I would rather name it as private A and private E, just to be clear about what am I doing. So the naming, I just modified a little bit. So I can tell by the name or tell by the CIDR block what am I actually doing. And so that's the way to think about just partitioning out your layout of your subnets. So what we just did was that in our availability zone, A and E, we have a 10.0.2.0/24 and a 10.0.1.0/24, two different subnets. Both of them are private. And so we have in E and A two different availability zones. This range of IP addresses, this range of IP addresses where we can deploy our application servers and our application servers. And if one of them goes down, no problem. And that's the scenario of HA. That's the building block, the beginning building block. When you want to create high availability, that's how you should lay out your everything basically. So think about HA from the perspective of putting eggs in multiple baskets. So you have eggs and you want to put them multiple baskets. So at least you will have some left if something goes wrong, right? You will at least have breakfast. That's the idea behind this concept of high availability at the very, very basic level. We can expand the concept and build out a scenario with complex examples, but you get the point. The point really I'm driving is using high availability is basically identifying different buildings from a cloud provider and putting your eggs in multiple buildings, like some of it here. You can have 3, you can have more. How many or how many number of different availability zones that the company will provide, like Amazon or Google? These guys, most of them provide these kind of scenarios, and even Microsoft. They will provide you with this concept of high availability as to how do you spread out your application, put your application one copy here and another copy here, another copy here. Now you suddenly have higher availability from a conceptual perspective. Now that is within the same region, like Virginia, for example, or maybe Oregon, for example. But you're not. If the whole region goes down, you're still screwed. Right? Remember that. This is just about buildings in the region. So they all belong to the same Virginia region. If the whole region is down, you are screwed practically. And the only fallback option is that you already have something like this here, and you just turn it on when this goes down. And that's a backup scenario. You can do a what I call disaster recovery scenario like that. But all of it, like the challenge that most small or medium-sized companies find is that the moment you talk about high availability, you're basically at least doubling your cost because you're doing everything twice. You're doing it in E, you're doing it in A, the whole thing. So you have a cost here, you have the same cost here, and then you're burning twice, which is okay, but at least gives you higher availability. And so smaller companies may not be able to afford scenarios like this. So they live with what I call poor man's HA. It is not really high availability at all, but it's the poor man's backup plan. That's the plan that most small companies end up doing in terms of, saving money, don't have too much money to begin with, so we do poor man's solutions. But that's not the mainstream solution. So mainstream solutions are actually not this. When companies have money, they actually deploy in multiple AZ and multiple availability zones, boiling down to a HA scenario. And that's what you will see as you will see me building this example. We have private A and private E, same concept. I'm going to rename the public to public, guess what? E. because that's what we have, the echo. This availability zone is E. So I'm going to name it E as in echo, E as in echo. And just to make it visible appropriately, making it capitalized so you're clear about what I'm doing. The scenario essentially is, now that I have two private subnets, but only one um, public subnet. So I can create one more, and you get the idea in terms of how we are going to do. Essentially, is to call it public A and select availability zone, and then give it some CIDR. Now the naming is kind of something that it'll work, but I don't like. I don't like the CIDR block numbering, because I'll tell you my convention on how I prefer to number these in a slightly different fashion. So right now I am saying create, but I would give you my perspective on how I prefer to number the CIDR block, so that even the IP address can tell me where am I really right now for a given machine, which building it belongs to, which availability zone it belongs to, whether it is private or public. And you can just quickly, by a glance at the CIDR, I should be able to tell. And for that, I have my own conventions to do certain things. These are just conventions. These are not rules. This is what I end up doing. Now, what I have done right now is against my conventions. This is not how I like to do. So I am actually disliking the whole thing. So I'm going to delete it eventually. But let me tell you what my convention is. And so you can modify that convention to suit your taste. And you can do that. It's purely a convention, but I'll tell you my convention. In the current scenario, we have kind of these two, private, or sorry, I should say public and private. Here we have the A and the E, A and E, and these are two different availability zones, and we have these kind of duplicate. Now, in an elaborate scenario, you may have something that is labeled differently. Something like, this is the border, which is basically public. So border, I call it as something that is on the boundary of the island. So we have this island, and this is where the NAT sits. This is where the bastion sits. And so that's what I mean by the border. So it is sitting on the border. So I call it border. And sometimes I will have an application layer. Sometimes I will have a database subnet. Sometimes I will have some kind of a load balancer that I will put it right here on the border. And that's how I will name. So this scenario where we'll have again two subnets, A and E for database, or some other type of scenario where there is another set of layer that I may want. And so these, what I call conceptual layers. So I'm dividing them like this and this. And so here is one, and here is another, and here is another. So when it comes to these divisions of what I call concepts, there is this border, there's application layer, there's a database layer. You can have multiple layers depending on the complexity of your applications. And so for each of these layers, I tend to have them on a separate subnet. Because the VPC is kind of big, we have 64,000 or so many, we can actually accommodate a multiple subnets as we feel like. So now comes to the point where we selecting CIDR notations. So what I tend to do, if you have an example where you have, say, the border, let's call these web servers, let's call these application servers, and let's call these database servers. So separate layers of application. So here, and again, we'll have multiple availability zones, like 1, 2, 3, for example, 1, 2, 3, 1, 2, 3 different subnets for every logical grouping of machines. So what I tend to do is I will identify that I will label this one as 10, 0, 0, 0 slash 24. Then this and this, I will label it distinctly differently. So something like here, let's see if I can write properly. Not really. Okay, like this, maybe 10, 0. Oops. You know what? I'll not write the tilted fashion. I'll just write horizontally and then fix it later. So I think writing it tilted is throwing me off. So erase. Let's see. 10, 0, 0, 0 slash 24. 10, 0, 10, 0 slash 24. 10, 0, 20, 0 slash 24. 10, 0, 30, 0 slash 24. And then I will alter this digit little bit here and here for these other guys. Like let's say we select A and C and E. A, C, E. A, C, E. A, C, E. And so this becomes 10, 0, 1, 1, 0 slash 24. And 10, 0, 1, 2, 0 slash 24. This is for A, this is for C, this is for E as an echo. So same way here, 10, 0, 21, 0, 24. 10, 0, 22, 0, 24. And 10, 0, 31, 0, 24. And this is just my convention. Nothing hard and fast about, these are not rules. This is just my way of thinking about how I would like to lay out the network map. And so same here, 10, 0, 1, 0, 24. 10, 0, 2, 0, 24. This is for C as in Charlie, this is for A, and this is for E. So now you see the layout, and by quick glance at the internal IP address, I can tell what that box is. Now I don't need to, but this is my OCD. You know what OCD is. So that's what it is. So, you know, I'm obsessively, particular about what I'm naming, what I'm labeling. And so something happens. Michael Curry says, I think I just lost the audio. Anyone else? I'm still good. Fingers crossed. No, it happens sometimes. Just refresh the page. That worked. Are you still having audio problems? Please speak.
No, I'm not
No,
anymore.
I'm good.
Okay, good. Okay, so if you want to chat, it is better to chat in Slack so that I can see, because this chat I occasionally miss. This GoToMeeting chat, I don't tend to look at that screen. I have three screens. I deliberately keep the GoToMeeting out of my sight because I'm focused on my writing and my chatting with you on Slack. So that's the reason I say please chat on Slack so I'll know what's going on. So that's my OCD. You got the point, and you got this numbering scheme. Nothing scientific. This is just my way of doing it. Now you may want to take it, you may want to throw it away. It doesn't matter. The core idea is for every concept or kind of logical groups that you want to put your machines in separate layers, that you want to put them in multiple availability zones, for which you need subnets, you need route tables, you need routes and everything. So all these guys are going to go through the NAT. They're all basically private, so they have to traverse through the NAT to go to the internet. And these guys, they go direct through the internet gateway. So that's how you will construct the route tables. So the route table construction is I think clear. You know it. You know it that the border people or the public subnet, as we called it earlier, they will all need to go directly through a gateway, and everything else we want to keep private. They can be web servers, app servers, DBs, and this and that, multiple layers. There is no limit to it. I mean, there is some limit, but practically it's a large set. So you construct out. Yeah, go ahead. Question.
Yes, so I can see that this can get really big really fast,
Mhm.
particularly if we have multiple HA locations and all that kind of stuff. Are there tools that help us create these, I guess, subnets and all that?
You wish. Yes, there are.
Yeah, I was going to say, otherwise it could get really nasty.
Right.
Yeah, okay, thanks.
the good thing is you need to know what you're doing the first by what I call first principles, right? I believe in doing everything first principles. So once you know the first principles, then you are golden. And you bring up a good point. Is are there tools to actually do this repetitively? Because I can do this boring stuff one time, but I don't want to do it over and over and over and over again. This is like a nightmare. So I don't want to do it over and over. Maybe I'll do it once and twice, but not more than that. I get tired. I mean, come on. So, yes, understanding it by first principles, great idea. Repeat maybe one more time, okay idea. But then third time, I'm not doing it. Sorry. So, how do I do it then? How do I repeat? How do I did whatever I did in Virginia in my account? Can I have Patrick do the same thing in his account? How do I basically copy and paste? Can I? Yes, you can. And so you can copy and paste. There are tools for that. These tools are called, let's see, what do we call them? CloudFormation. That's the tool. So we will cover it. There is a method here called creating a template from your existing resource. That's the thing we will use. So this idea of creating a template from your existing resource is basically copy command like this one, and then create a stack is basically the paste command, where you have a template, you're just creating a new stack based on a template. Paste. That's the paste operation. So you create a template, and then you create a stack. So in my account, this is Nilesh. I will do the work. I'll do all this grunt work and more of it, right? Not just this. I don't stop here, by the way. This is just the network. Then I will create machines and machine images and configure them, put applications and the whole thing. And then I will do copy and paste. Copy by creating a template. And then paste into Patrick's account by creating a stack. The idea essentially is called, what's the name? CloudFormation. It is a service. It's a free service you have here under management tools. CloudFormation is create and manage resources with templates. So we'll get to that at some point. But for right now, you get the answer, which is yes, you can. Yes, you can copy and paste. There are other open source tools. The problem with this tool is that it locks you to Amazon Web Services, right? Once you create a template using Amazon Web Services, then you are basically married to Amazon. And I don't like that. I mean, I don't get married with companies, so I don't do that. So I would rather not use this tool. So what do I do? What do I do? So there are third-party open source tools that I prefer, and not this. I mean, there are pros and cons of the discussion. CloudFormation, yes, you can use. It's very exhaustive as it comes to Amazon, but then there is this thing that I prefer. Which is a open source tool set, does the same thing. And it basically lets you build, combine, and create infrastructure. So you design something, you create a blueprint, and then you apply the blueprint to another scenario, and it builds it out for you. So you can play with it. And there is a simple command called Terraform apply. And so you basically, we'll do the exercises on this. So there are tools available. And yes, that's what the second segment, which is going to start, is kind of giving you these are advanced tools, by the way. So we'll get to them at the third segment. Absolutely. for right now, we are doing first principles. So we are understanding what does it take, understanding how do we lay it out, understanding the ideas of how actually things connect, how traffic flows. Make sure that we are cool. When I say cool, I actually mean crystal clear.
Hey, Nilesh.
Yes.
So I have a couple questions. The first would be in that HA setup that you're showing with A, B, and C, or A, C, and E
Uh-huh.
uh, buildings. Um, would you actually need? I mean, are you just showing examples, or are there actually cases where you would use three levels of redundant or two, levels of redundancy there?
Two is
Because I
good.
guess it's
Two is good.
yeah. This
Yeah.
is,
Yeah.
and then I guess the other question was, um, so you're talking about actually duplicating the entire cloud. Um, so you'd create another bastion for B and C, another NAT for B and C, and then each machine on your private net you'd have to create for B and C as well.
So the bastion is not needed for these guys. You can just have one bastion because the whole VPC you can access through one bastion.
But what if the bastion goes down?
Then you create another one and use that one. So it's bastion is like a transient thing, right? Bastion is you can kill it, you can create another one and still go through that one. So bastions are throwaway material. So you create them. You don't necessarily want to throw them away, but you can have a tiny little box. Leave it alone. If it dies, you can just create one more and go through that one. Not a big deal. It's not the
Well, I get
main workload, right?
yeah. Well, I guess it's not the main workload, but if you have, a set of users that use the internal network, and they all have to get through the bastion. Then if the bastion, fails, then nobody can get in.
Correct.
So it's
And
not
in
like
that scenario, you have more than one bastion and do what I call failover scenario between bastions. So you have at least say two bastions, B1, B2, and you watch whether the other one is active or not. And if one of them dies, you basically kill that one and create a B3 in its place and bring it up. And so
oh, okay,
yeah, so you have to
okay.
keep watching whether they're dead or not. And so same scenario for failover, you have to have in NAT devices. You have to have two NAT devices, one in say A and the other one in E. And these NATs, NAT1 or NAT A and NAT E, needs to be able to fail over. Now that was the case that we will need to do if you're doing a high availability NAT scenario. You want to have your active machines to be able to connect through one of these NATs and just go out to the internet as and when needed. So NAT high availability failover scenario, you have to actually monitor whether the NAT is responding to me or not. And if it doesn't respond to me in a given amount of time, I will assume that the NAT is dead and kill it. If it doesn't respond, I can safely assume the NAT died. So I'm going to kill it out, create a new NAT, and put that one in service. It's an assumption. Until that time, I will fail my traffic over to the NAT E and let the computers access the public resources on the public internet through this NAT E until that time. But if one of them doesn't respond, and there are you can write code, very simple code that basically looks at whether these machines are active or not and kill them
Easy.
proactively. Like just if they don't talk to you in 5 seconds, kill it, get a new one. That's how it should be written. Now, having said that, Amazon has expanded this idea into what they now call NAT Gateway. As you saw, it is like December 15th last year is when they came up with this new concept, which is taking care of all these things that I just described to you. The NAT high availability concept. They are doing it for us. They don't show us the NAT devices when you start a NAT gateway uh, here. When you go to say VPC and start the NAT gateway here, and you start a new NAT gateway and all that, they don't show you your NAT devices, but then they are there. And they are not just one NAT device, there are failover devices given to us just by the fact that you are creating a NAT gateway through their interface. But behind the scenes, that's what they're doing. They're creating a failover NAT for you. And so similarly, if you have have a bastion, multiple people want to connect, you want to create a failover bastion setup like this. And if one of them just doesn't respond, you assume that it is dead, move on, and get the next one, and put that in place. So that's the scenario from a bastion and NAT perspective. For all your machines, like you might have in the let's this is an overkill, by the way. A and C and E, having C is kind of too much, but then certain applications need that, so we can just account that. So right now, let's say we have only A and E. That's good. Now, having done that, we will lay out our web servers in the A subnet, in the E subnet. We lay out our application servers in the A and E, database servers in A and E, and have a database failover like this. And same scenario here, failover here, and the border will have NAT failovers like this, and bastion failovers, B1, B2, or BA and BE failovers. We can have those failovers and make sure that our infrastructure keeps on working. And if it doesn't work, we'll assume that these guys, if the web server doesn't respond, we'll just assume that it is dead and create a new one and move on. That's the idea behind what I call cow versus pet. Right? In pet, you worry about the pet. In case of a cow, you just kill it and move on. That's the concept. So that's how you should think about. That's fundamentally the only difference in case of a real data center and a cloud scenario. The concept essentially is this: is it a cow or is it a pet? You want to shoot and move on. You want to behave like a cowboy, although people will question that. But in cloud context, it is okay to kill a machine. It doesn't hurt. So that was the
Just a quick question.
Yes, keep going.
Just a quick question. So this is fine for this, but a lot of the environments I've worked in is high availability isn't described as having multiple machines in the same building. It's actually multiple machines in different regions, meaning maybe one in Chicago and another in Blue Ridge, Virginia.
Yes.
And we do that here because
yes,
that's what I worked in 5 years. Okay.
In the scenario of disaster, like you have a machine in, say, New York and a machine in New Jersey. That's a most banks will do it like this. They will have optical links, and the optical links between those two locations, and the banking operation will keep on working here. And every time, in fact, the optical links that we in my previous company, I used to work for this company called EMC, where they had a product called SRDF. They still have it, Symmetrix Remote Data Facility. The idea is that you have a disk here, and a disk here in New Jersey, and one in New York. And so you have a banking transaction happening. You save the transaction to the hard disk. This is a disk. And so before the disk acknowledges that, yes, I saved, before it acknowledges back, the disk actually copies it over to this disk in New Jersey, and then gets an acknowledgement back, and then says, okay, I actually copied, which basically means you have transaction integrity between two geographic locations. Now, that is a very expensive proposition, but banks do that all the time. In fact, when this 9/11 happened, you had the bank went down. The banking transactions just automatically failed over to this location, and it went on working. There was absolutely no issue from a banking perspective because it was totally a failover scenario and transparent failover scenario. So you don't see this advertised as such because it was 9/11. People don't talk about it too much. But the idea is when you're doing transaction level transparent backups like this, before you save to this disk here, it is actually saving to the remote disk, getting an acknowledgement back, and then saying, okay, I acknowledge I got the data and I wrote it. So the disk write comes back saying acknowledge. When you write something, it is writing in this place as well as this place. Now that's the level of complexity needed, and we are not talking about that in here in this example. We are talking about, say, 5 buildings in Virginia region. We'll call them A, B, C, D, and E. We are not talking about what you just described, which is disaster recovery, having something in Chicago and Seattle. That is not the scenario. They're giving you HA within the region. They're not giving you across regions yet. So you don't see that here. You cannot have a VPC belongs to. So if you create a VPC, it basically belongs to a region. See, you cannot select multi-region VPC. This is limited to the region you chose. That's it. And you just work one region at a time.
Okay, that makes sense.
So that's how the current layout of this Amazon cloud is. And that is similar with Microsoft Cloud and Google Cloud. Same idea. They're not doing it. This scenario is very expensive. It used to cost like $1 million just for the disk. I mean, talking about this disk, $1 million. It is still expensive, but not million. It's called EMC Symmetrix. That's the product. I used to be the product manager for this product. This was the box, I remember. And this is basically a collection of hard disks. There are about 600 so hard disks in this box. And this itself represents, the box itself looks like a hard disk to a computer. This is a disk array. It had a little computer. This is like a monitoring workstation. This will shut down, the laptop will shut down, the door will close, and this whole thing will look like in those years. Today it has more capacity. Like there are 1,440 disks. When I was there, it was this machine, 576 disks. So it was exposed in that 2003, those years. These machines were my puppies those times. And so the idea is you are exposing that disk out to a computer, and you can connect multiple of them. So you can have this disk, Symmetrix disk, connect to a Windows machine, a Sun machine, a Apple machine, or mainframe machines, and you can connect them at the same time. And so that's how the usage scenario was for storage area networks. And I'm pretty sure Boeing uses something like this right now. They have it. I've seen it in Microsoft also. And so that's how data centers are laid out on the back end. That's where your disk is actually presented to Windows. So when you say Windows E drive, E:/, this disk actually is sitting somewhere here. And in Sun or in other Unixes and Linuxes, you have the disk in Apple volumes and mainframe, those things that you expose like a disk is actually away on a storage area network. But these kind of hardware are expensive even today. And so that is not what you're getting. What you're getting is what you see here. And the prices are pretty darn cheap. You know the pricing, 0.065 per hour, something like that. So it's pretty affordable. Yeah, not $1 million. So different in price, right? So just saying. So that answers your question. Next. Okay, let me quickly check one thing.
Can we talk a little bit about,
Yes.
and maybe this isn't really the right area to talk about this, but the idea of virtual IP addresses and how that would work in HA environment.
When you say virtual IP addresses, which one do you mean?
I don't know exactly. I was hoping you might help me with that. I just keep hearing about.
Okay. So
everybody's asking us if we're going to support virtual IP addresses, and
so
I don't know.
So what people maybe I really know what they mean by virtual IP addresses, but the scenario.
Sorry, I was going to say, well, at least at Boeing, I understand virtual IP addresses is like, let's say you have 2 web servers. One is your main active and one is your passive backup. You could have an IP address that points to the one that's active. So the IP address maybe you use a cluster manager or something like that, the IP address is going to point to the active server, and it's basically an alias to the active one. So it's really just an alias. I mean, that's what it is.
So I think I think I've understood what you have in mind, and I can elaborate on what this virtual IP might be. Now, I have not seen it, but I can tell you what it is.
Yeah, and how it relates to the Elastic IP, because that's an Amazon thing, right? The
Yes, so
Elastic
this
IP.
is an Amazon thing,
I
right? Yes,
don't
this is
understand it. And how that ties into F5 load balancing. Anyway, the whole thing's a big
I get it.
mystery.
I think I got that. Okay, let me elaborate now. So in Amazon language, the thing is called elastic IP address. In OpenStack, it is called floating IP address. OpenStack is an open source management tool for cloud that you have it deployed in Boeing. So that is floating IP. Amazon uses this name. Your company seems to be using this name, virtual IP. And you're talking about these tool sets, load balancers and F5 network. So now let me draw some primitive diagrams to illustrate the point, which is what I think what you are talking about. I think that's what you're talking about when it comes to virtual IP. That's what you mean. So here it is. I have machine M1, M2, and I have only one domain. And this domain happens to be the CloudGenius domain. Now this is a record. This points to some IP address. And I have two machines now. So which IP address? Is it this one? Is it that one? Do I know? Do I care? And if so, which one should I use? Should I use this one or that one? I don't know. So how do I figure it out? That's where virtual IP addresses come into play. So a scenario would be when I have a machine M1 and a machine M2, and both of them give me IP address, let's say 52 dot, or rather, I'll not give a particular number, but just leave it at this. So we have an IP address from here, IP address from here. There are two different ones. So this is IP address number 1, this is IP address number 2, and I have no idea which one do I use. So my traffic that comes along from outside, like people who attend and visit my site, these guys, and they come and they visit my site. So each of these boxes has a different IP address, right? IP1, IP2, 3, 4, like that. So I don't know which one to use. So what I do is I put this device. This box is called a load balancer. You can call it F5 networks. You can call it elastic load balancer in Amazon, or you can call it HA proxy in open source. By the way, this is exactly what F5 networks uses, and a variation of that is elastic load balancer. And this HA proxy is a open source load balancer. It balances the load. It is the scenario being you have these, you come to the US from a foreign country. You enter. At the gate, you have a cop. The cop says, you go to this officer number 1. You go to officer number 2. So people are lining up, right? People are coming into the country, and this cop is the arbitrator. And he or she will say, you know what, there are these stations, officer number 3, officer number 4, and like that. So lots of immigration officers sitting here, and they will arbitrate. You go here. Okay, that one. Next one, go here. Because this guy is busy, right? So you skip him. The third, you go to the third one, and you, by the way, should go here. Okay, that arbitration is what this cop is doing. That's exactly what this scenario is, where you have the arbitrator, which is the load balancer, which is the F5 network, which is the HA proxy, which is the elastic load balancer. All of them basically the same thing. They do the same thing. The doing part is that this item says, you go here and talk to this machine, and you go here, talk to that machine. And so that interface, the traffic flow, or the, sorry, not this guy, you come here. And so the idea behind these machines and these people is that this arbitrator is assigning people to different machines like that. So oops, this guy goes here. And so you know the concept. Now, having understood that part, how does the IP addressing scheme plays? The scenario is that you have to have this will give you one IP address, like it's only 1 point. So that is the IP address you want to use. However, if you go look at our elastic IPs and try to get a new address, and I'll say yes, allocate. What I just did is I rented an IP address. What is my IP address? Let us go look. My IP address is 52.72.129.164. That's my IP address. I just have it now. I'm going to pay for it, and I agreed that I will pay. So that's the IP address I have, which is right here. So I am going to, sorry, I think I did not copy it properly, but you get the idea. I got the IP address from this location. Am I using it right now? No. Is it connected to anything? No. Is it connected to any particular endpoint? No. So how do I make use of it? That's the idea behind keeping it virtual. Thereby, I can assign it to wherever I feel like. So now I have this load balancer and 3 machines, M1, M2, M3. And I have the IP address assigned to me by this load balancer. So I get an IP address here, but I actually want to use my IP address, which is this one, right? That is my IP address. So I want to use that one instead and not get this random IP address that the load balancer might generate. So I'm not interested in that one. I want to use this one because that is my permanent IP address that I want to associate with my domain name, BA Cloud Genius, so that I don't have to keep changing my record. So that is frozen, permanently done for me. I'm paying for it. So I can just have this route to this endpoint and say, okay, here, you go there, and then you connect. Sometimes you don't have a particular load balancer at all, and you might have just one machine. So when you just have one machine like this, which machine do you want to serve it from right now? You can say that I want to have this IP address mapped to this endpoint, and that is okay. It will map to that endpoint, and then every traffic will just go straight to M1. Tomorrow, you might decide that, you know what, I want to actually have a NAT gateway. And so I will then create a NAT gateway, and that NAT gateway needs to have a elastic IP address. So I can then decide that, you know what, my allocation that I have currently going to M1, I want to change that, and I want to assign it to my NAT gateway, because that is what I am more interested in right now. So I will have this entry point to NAT gateway. So it is flexible, it is kind of virtual, but it allows me to retain my name number mapping, name to number A record mapping. At the same time, gives me the flexibility to move around the IP address itself wherever I feel like. And that is the idea of a virtual IP address, which is very similar to OpenStack's floating IP address. You basically get an IP address and then use it. In the case of Amazon, the same concept is called elastic IP address, and I just have one, this one. I can release the IP address, and then when I do that, I don't get charged anymore, which is nice, but I want to actually associate this IP address, click, with some instance that I do not have, or some interface that I might have. No, I do not have. So let us get rid of this release address. So cancel. I don't want this. Is in this region, I don't have any machines. Let's go to another region where I have machines. So here, and in that region, Oregon, I have a one machine. I think one machine is there. So here I don't have an elastic IP address, so I'll get one. And here I have it now. My address is a different address this time because it's a new allocation. I have a slightly different IP address, which is this one. And if I am going to use this IP address, I can associate that IP address with some machine that I might have. So what do I have? I have an instance running. It is this machine. So I can just associate that IP address, which, by the way, before I associate, I want to show you what its current IP address is right now. So watch this. This IP address is 54.69.167.139. Remember that, 139 at the end. Now let us go look at the machine itself. Amazon EC2 dashboard running instance. This machine has an IP address of 23.19, which is different, right? I can change it by going to the Elastic IP address section and saying that I want to associate this instance and make sure that I associate. If I associate, my website will immediately stop working because of a simple reason. I'm associating right now this name that I have, the BA Cloud Genius site, whatever that name, it is currently mapped to the number 2319, right? 23.19. That's the mapping currently on an A record. If I associate the virtual IP, the elastic IP, the floating IP with this machine 23.19, then I will click the associate button. At that time, my new IP address of the machine will become my virtual IP 167.139. So this will go away. 167.139 will take its place of the public IP, which means my A record is broken, which means my site will stop working right away. Which means before I associate this public IP with my machine that I have, I want to first, or maybe almost do these two things simultaneously, right? I want to update my A record and point the domain name, the domain, directly to this IP address, which is the public IP, which is the virtual IP, which is the elastic IP, which is the floating IP, same thing. This IP address, that association between the name and the number has to happen. And at the same time, I want to associate this public IP or this virtual IP, this elastic IP with my machine M1, which means I'm releasing that old one and just using this one because that is my permanent elastic IP or virtual IP that I can throw away at any machine I feel like and use it and keep using it. So tomorrow, if I decide that this machine is causing me trouble, so literally what I will do is I'll shoot the cow and start a new machine, M2, and have my site running there. Takes me like 5 minutes. After shooting the cow, I can get the new site here in 5 minutes. And then what I need to do is relinquish this association between this address and that machine because that machine is dead, and instead take this address and associate it with this M2. And that's the concept of a virtual IP address. You can basically point it to wherever you feel like. M1, oh, M1 is bad, no problem, go to M2. And so then you break this association, establish this association, and you are maintaining 167.139 IP address as your virtual IP. And you can reuse it. The scenario that I just illustrated is an example. You can reuse it. I don't want to necessarily disturb my setup, so I am not associating, I'm actually canceling it out, but you get the point. So does that answer your question?
Yes, it does. That makes perfect sense. So you could hard code that elastic IP and change machines however many times you want to and not have to worry about it.
Yes,
you're still pointed
correct. Not only that, okay. This idea doesn't limit itself to machines, but not limited to machines, but also You can say, you know what, forget the machine business. I want to use it to a load balancer, elastic load balancer, or F5 networks, or some other HA proxy box I might have. HA proxy box. So each of these things basically are the same function. They function the same way. These guys have an IP address, and you need to have this mapping that you have it to M2. You can map the same thing to here. And these guys will then front end your multiple machines, M1, M2, M3, like that, and like that.
Yeah. Yeah. In fact, that's how you map CAS boxes in Exchange.
Yep.
That's exactly what you do.
Yep. Exactly. So can you expand on what CAS is?
Yeah, it's a client access server.
Oh, I
so
see.
client,
okay, yeah, Windows client access. Okay, got it. Yes, exactly.
Yep.
So you can then basically serve a large enterprise workload of Outlook clients, right? That's what you mean by that.
Exactly, and then it'll route it to the correct mailbox and all that kind of stuff.
Yes.
The architecture in 2013 is a little bit different, but yeah, it's basically the same.
Yep. So you have like 65,000 Outlook users in Microsoft, and you want to map them. So you want to have some kind of a load balancer scenario and multiple Exchange servers here serving different mailboxes, or maybe sometimes same mailboxes on multiple servers, and then lay it out. So to address that balancing of load, you need some kind of a balancer, and Microsoft has their own load balancer, and they're not these guys, but the idea essentially is the same thing. And you can have this endpoint is what you will give to your Outlook client, or you can give it in the auto discover function in Outlook, right?
Yeah, they call that a VIP, or a virtual IP address.
That's right. Yeah. So the concept is basically the same thing. So if you go to, say, let me show you something which you might find amusing, is digautodiscover.microsoft.com. See that? That's the IP address I'm talking about, which is what get discovered. So this IP address, there are two of them apparently, HA scenario right there. And so auto discover is the first hit point where Outlook will attack to identify, okay, where do I go next? And that, Patrick is an Exchange expert. So he can tell you more about it. If you have a further thoughts on it, go elaborate. But this is the IP address, which is basically a virtual IP address that is pointing to the gateway, the front end, the load balancer, the whatever you call it, CAS, which is basically this arbitrator, this guy. Okay, cool. So if you want to take a short break, I think it's a good time. We'll take maybe 5-minute break. Right now it is 7:08. So we'll 7:15 or 13 maybe. We'll get together. Until that time, we'll talk no technology talk, no tech. I have learned that now. I'll never repeat that mistake. So yes, I'll be quiet. We'll not talk technology. Take a break and come back. And we'll switch topics. I want to talk about something different, not infrastructure, but the other two services like platform and software and things like that. We'll take up these concepts and build them up in the architecture section in the third segment further. That is what we intend to do. But for right now, take a quick break and come back. I want to check whether our friend is online. I think I saw him, but I don't see him anymore. He is not there. Okay. But he was there a few minutes ago. His name is Alex, and he had a problem, major loss in his family. I think
Alex Ramos?
The other Alex Veloz.
Oh, okay.
Ramos is okay. He's doing okay. But other Alex had a major loss in his family. So he was out the other day. I think one of you guys helped me connecting with him. He came back online and then told me about this. So he's busy doing his thing, but he's catching up. So I was just trying to see if he's still online. He's not, apparently. No, he's not there. So what do you want to talk about in the break? Nothing? 7:10.
Well, we can always talk about the Super Bowl.
Yes. So maybe the halftime show?
Well, they were talking today. I saw somebody talking about the cost of the Super Bowl advertising, and I can't remember if it was more expensive or less expensive. But the ads are going to be a big deal again.
Interesting.
Or it's supposed to be like $4 million for 30 seconds or something like that.
Wow.
Yeah, I guess last year it was $3 million. Is that right, or something? So it's gone up another $1 million for this year, or something like that. It's crazy. Yeah.
Yeah, it's like rent in the Seattle area.
Rent in the Seattle area. Wow. Yes, I guess that is true. In the kind of rental market and the housing market has.
Yeah, but try to rent in New York or San Francisco.
Yeah, try to own here.
Oh man.
Oh, I actually moved here from San Francisco, but I moved up here because it was cheaper. But who knows? Sooner or later it's gonna catch up.
Yeah.
I guess you were paying for that view. Sorry, go ahead.
Just after the Loma Prieta earthquake, it was actually pretty cheap.
That was '89.
Oh yeah, I lived there in '89. I could actually get a one-bedroom apartment for $685 in '89. I tried to get
I was 5.
Is politics off limits?
No, nothing is off limits. No technology though. That's it. No technology.
Actually, it better be off limits. After 5 minutes, you might have half the people leave now. But no surprise. I'm shocked Martin O'Malley didn't get more votes yesterday. No, just kidding.
I should express that my thought also, which is I'm happy that Trump did not gain the top of the listing on that list that we had, whatever that was, like second, right? Which makes me happy. I mean, I don't care anybody else wins, but I don't want him to win. That's my thinking.
Yeah, he does. I don't know.
I just don't want him
weird.
to win. Yeah.
It's the backlash vote, I guess.
I know.
Anti-establishment. It's funny to see their reactions, though. Like, Hillary squeaked it out against the Vermont senator, by less than 0.5%, and she's like, "Wow, this is great. I'm feeling really good." And meanwhile, inside, she's like, "Man, didn't think it would be that close."
I know.
It's all relative.
Face, yeah.
It's all relative, right? Because the Bernie Sanders campaign acts like they won, and Hillary Clinton's campaign act like they lost because there was expectations, right? That's what's the key.
Yep.
Right. It's with respect to how they were going to finish. Like Rubio too, the same thing. In his eyes, he won. He was a point behind.
But he was third. He was third, but he was third, but they acted like they won.
Yeah, I mean, in all parties aside, whether you like, if you happen to be on the left, if you like Sanders or Clinton, I mean, let's face it, Sanders isn't going to pull New York and California and Florida and Texas. I mean, it doesn't matter to me because I tend to be right of center, but I don't see him. It doesn't matter to me who wins on that side, but I don't see him. I mean, even if he'd won, and even if he wins New Hampshire, and even if he wins South Carolina, is he going to pull the big boy states like Florida, California, Texas, Ohio? Washington. I mean, I don't see it happening.
Okay.
I don't know.
Yep. So let's get back. So what I want to discuss next is we had a decent amount of discussion on and exercises on this aspect. We will pick up more of it as we go along in the second and third segment, and you will see that in DevOps, and you will see that in architecture, probably a little bit deeper in here in terms of with examples of various industries and things like that. So you'll see that in here again. For right now, in our technologies section, what we are basically going to cover is those services like infrastructure, which we did. Platform is the next, and software, which I don't want to cover because I'm betting money that you already know it. If that's not the case, let us talk. But maybe I'll take like 5 minutes and finish off this checkbox item for me. It is okay. What is software as a service? If you find that I'm going to trivial, just tell me. But I'll elaborate some of these aspects to cover the topic. Make sure that I do justice. Like I'm just doing a checkbox item right now. 5 minutes, not more. The idea essentially is this idea of TurboTax, turbotax.com. That's the app. So you sign in and you basically file for your return. For the easy form, it is 0. For other forms, it is not 0. And the pricing is available. Now, what's going on under the covers? You are basically not even worried about technology. You don't care about any resource, no CPU, no network, no disk, no storage. You don't have to worry about any of that. All you worry about is taxes and return. And more importantly, refund. That's what you care about. So from a usage perspective, it's the user. And that user pays money and gets service. And that service is software as a service. You're getting some software that you're using on a browser primarily, sometimes software that you're using and you're renting. So for example, here is a PowerPoint application starting up. And on my recent documents, if you look at this Cloud Genius course itself, there is a PowerPoint file that opens up. And the same scenario, if you look at the same scenario, you can see the same exact setup and layout. Let me see if I can illustrate that point in a quick fashion. Let us see if that pops up. And okay, so here you see my iPad. The same exact thing you're looking at, again from PowerPoint, same application coming up. And the same kind of recent items opened up also show up. You see the same thing showing up in my iPad as you see in my Macintosh. Item by item is the same. You can compare and see that the items that are for today and older are matching up. In here, it is still refreshing, but the idea is that I was working on this Cloud Genius course PowerPoint presentation yesterday, and that is exactly what you see here as well, and on the iPad here. So the scenario essentially is that Microsoft has built applications like applications that are connecting to the cloud, to the essentially this is the OneDrive cloud that they have. And so the app from my Mac, the app from my iPad, the app from my phone, the app from my Bootcamp, Windows Bootcamp, PowerPoint, they all are basically getting served by the service, which is known as Office 365. I think you know this already. You know how to use it. There is no rocket science in using it. The rocket science is actually in building it. So the applications that you can use the app on Mac, app on iPad, phone, Bootcamp, Windows PC, Surface laptop, things like that, Dell laptops, all those things. So where you have a PowerPoint application, you can then hook up to the same service available to us through Office 365. But there is one more, which is the browser. And you can use the browser interface to access the same thing, just like this. OneDrive, what's the name? Live Drive, OneDrive, SkyDrive, OneDrive. So the same scenario you can see here. I have my OneDrive and my files stored in, I don't know where I stored it, but here, an example file, ATO keynote. So this is Mark Russinovich from Microsoft talking about some PowerPoint deck talking about Linux in Microsoft. And that's what he's saying. So the PowerPoint slide deck is opening up and he's talking about Linux and he's singing open source and all that good stuff because Microsoft has changed. And so they are now into open source. They're using it, getting their own distribution of Linux is now available and things like that. Basically, open source is what you are seeing in Microsoft, but that besides the point. The idea is on the browser, you can edit the presentation inside a browser like this. And this thing, what you're looking at, is called PowerPoint Online, and it does not require the local application. So you have the apps on the Mac and iPad and iPhone and Boot Camp and Windows PC and all that. None of that is required. Absolutely none of that, because you can use a browser, connect to Office 365, and connect to this using browser. And this is also possible and valid scenario, and that scenario is PowerPoint Online. You're looking at one right now here. This is a browser. It is not the PowerPoint app, but you can operate on the slide deck just like you would with PowerPoint on a local machine. So they're talking about whatever they are, and you can modify the deck. The bottom line being, you can change and make changes to the PowerPoint slide deck with a browser in hand without having to worry about any local app. You don't need PowerPoint to work with PowerPoint. You don't need PowerPoint, and that's the service. Now, similar to that, there are other services from a variety of companies. And the whole idea essentially is that the company who is building a software as a service is using some platform underneath, which in turn uses some infrastructure underneath, which in turn uses actual hardware, and so on. So this
So
yes. Go ahead.
Well, yeah, so what might be more interesting to us is, let's say a company is right now on-prem. So it does everything on premises. It's got its own hardware. And they come to us and say, I want to take this application that runs on-prem, this application, and I want to migrate this now to the cloud. I want to make this software as a service, and that may be more appropriate for our interest. And how do we migrate that into the cloud?
Makes sense.
Does that make sense?
Yes, I understand. I understand what you're saying. Let me begin. There are a variety of ranges. It's a spectrum. The migration techniques is a spectrum. There is a crude idea, very, very crude method, and a very highly sophisticated method. And that is the spectrum. The crude way, the really, really bad way, I'll tell you what. You have the app on premises. You just put that app on a VM and take the app on a VM and put it in the cloud, and it will suck. It will be bad. Performance will suck. Really, really bad. But that is one potentially possible way to just cut the local premises and go to cloud. That is one potential possible way. Again, it depends on the application itself as to how chatty the application is, what resources it requires for users to connect and send and transmit and receive between the application in the cloud and themselves, and a variety of scenarios. So the flow that you should think about when you're talking about migrations, this is a crude method, like really, really bad way. The sophisticated way of doing is very expensive, but it really is diligent and very, very beautifully. You have to think about how to think about. So that's what I will focus on in helping you understand for a given application, which is not Microsoft Word. I mean, I'm not calling it it is an application, but that's not what people are talking about migrating. People are talking about migrating some app that they may have developed in-house, or may have purchased from outside and are running it in-house on their own premises in a data center. They're not talking about Microsoft Word application. That's a custom application they might have. So in a given scenario, they might have a data center in which they will have some database of some sort, some kind of a web server, if you will, and some internal users who are all within the data center location, or maybe the on-premises, so the whole campus, if you call it premises. So these are the premises, and you have your internal users sitting and accessing the web interface, and the web interfaces in turn accessing the data interfaces, and all of that is in the campus on premises. That's the scenario. Now, the latency or the transport time it takes from this computer, from the user's computer that you have, this user, he or she will connect to this web interface. The latency or time it takes for the traffic to go back and forth is very low. The bandwidth available within the premises is very high. High bandwidth, good. Low latency, great. I mean, great. It is awesome. Now, all these benefits just disappear the moment you increase the distance between these guys and this guy. Just move this guy away. Okay, let's take this guy and put him away, like far, far away. So just put him outside, like right here, outside the premises. And now he or she is connecting far, far away to the data center on premises. This is a typical scenario of a traveling user. So you have a user traveling and connecting through VPN back to the corporate. That's the scenario. Now, what you will notice if you have seen this scenario is the traveling person finds that the network sucks. I mean, so bad I cannot get my thing done, could not open my reports, could do nothing, my application is horrible, all that complaints come along suddenly because you lose two critical things right there. One, you lost the bandwidth that is otherwise available to this local guy. This is the local person. And this guy is the traveling person, right? The traveling person suddenly complains really bad latency, very long duration of refresh, very low bandwidth, right? Low bandwidth, high latency. And both of them suddenly reversed. This reverse, this reverse. So both of them are bad now. Bad for the traveling guy, still good for the local guy. Local guy is happy. So think of him as the internal person in the campus, and he says, what's the problem? My application works. What's wrong with you? So that's the scenario. What we just did is kind of simulated a cloud setup. To the traveling person, this whole thing is in the cloud. And that's what will happen when you physically take the application, the data layer, the web layer, or all of that, and just brute migrate in a crude fashion and put it out in the cloud. Because what you just did is that you have everything on premises and your machines and your user, they're all right here. So you have high bandwidth and low latency. Great. Now you suddenly move this guy away here and the thing's reversed, which means these benefits go away. Now that's one way to think about. The other way to think about the same thing is you have the on-premises and you have the guy still inside, but your machine goes away on a travel. The same problems appear again, except your person is here, but your machines have gone to travel to the cloud. The same problem you will see when a traveling person connects through the VPN back to the data center and complains about problem, doesn't work, this and that. You will see the same thing happening when you put the machines out there in the cloud. The same exact problem will appear unless, let Let us see what those aspects are.
Well, there's another thing too, and that is the corporate policy requires the users that access that machine, they have to access it using a VPN.
Yeah. Right. So the same scenario, you will also require a VPN to your VPC. So you have a VPC here. That is where you will put the items in the cloud, and you will still access from your premises. You will have a VPN connection to your private cloud, or maybe a Bastion tunnel connection, one of those, right? So you will have either a Bastion tunnel or a dedicated VPN or some other connection to the cloud, which will be not as good as it would be if the whole thing was right here, right? They're in proximity. So proximity beats every other problem. So, just high bandwidth, low latency will solve most of the problems already right there. But that is not the case when you go away and you take the guy away to the cloud, or maybe take the machine away to the cloud. One of those scenarios, the conceptually the same thing. So when you have a premises, and those on premises that you have a building and you have people sitting here, but your data center is the data center is kind of gone. It goes away to the cloud, right? So this goes away, and you have a VPN connection to your VPC. And all of these people in your company, they're all basically going through this pipe and are accessing the machines that are now sitting away from you. That's the problem. You just flipped it. Now, the problem still exists as long as this VPN is okay and you have a low latency connection, and bandwidth is good enough, you can survive. It'll be happy. Your users will continue to smile, right? They will continue to be happy about what you have, even though you have migrated away to the cloud. But getting a low latency, high bandwidth connection to a cloud scenario is expensive. That's one problem. Not every company can actually afford to have a very high latency, low latency, high bandwidth connection to any cloud company. Not everybody has it. Let's be practical about it. It's very expensive to get a connection, a dedicated VPN connection, or some kind of a direct connection between a cloud location and you. It's very expensive. So what's the other alternative? The other alternative is to think about how your application is actually written. So the original application that you have on premises, it is very likely that, if you're talking about migration, you're basically talking about an old app that people are not maintaining. Or maybe they are maintaining, but they're maintaining without thinking about those bandwidth and latency problems. They're not thinking about security implications. They're not thinking about what that might be if you have. So let me give you an example. I think that's the best way to think about. So you have an app, very simple. So let's say you have a very, very simple scenario: web server, database server, not much. So that's it. There's a database. Let's call it a database called MySQL. If you're not familiar with it, it is a database owned by Oracle now, and it is open source. So they own it, and so that's an open source, very popular database in use today. Another database that people are extremely finding useful is this database that you may have heard of. It's called PostgreSQL. Another very popular database. These are structured databases, RDBMS databases, That's so we're taking this example, and this thing needs a port open, 3306. Now, in a on-premises scenario, they might leave the port open to anybody and their brother and their sister, and it's all on premises, so not really too much worry about security as such, because the whole thing is guarded, right? We don't have to worry about. So that's the scenario that I'm painting right now. Now imagine if you take the same setup, put that in a cloud context, and you by accident leave this port open for access from outside. Now you have a problem with security. That's a way to think about. Another scenario, you have web server that is internal, but then you are opening up this port number 80 for this user, which is okay, and you need to, but then certain other ports are accidentally left open. And you're not even thinking about it from a security standpoint, from an audit standpoint, from making sure that your infrastructure is tightly controlled, because all of it is in premises and nobody really worries about it, anything. So if you take a forklift and move it out, you will have a big problem. Instead, thinking about security, thinking about a performance expectation of the application that runs here on the web server and interfaces with the database server, that interaction, that chattiness, how frequent, how periodic, and what quantity of chunks of data flow between the application itself and the database. You have to understand that sizing, and also the amount of flow of data between the user itself and the web server, the interface between. So think of it as a pipe of information that flows between the user and the web server and the database server. How is that pipe, how wide the pipe is, and how smooth the flow of data goes, and how big the capacity of each and every connection is from a flow perspective. Does the water flow, or is the pipe too narrow? Is the pipe too wide? Both of them are a problem. If it is too narrow, that's a problem, because then traffic will not flow, water will not flow. If it is too wide, that's also a problem, because it is expensive to have a wide pipe, to be able to make sure that if it is all within the same location, that's okay. You can put web and DB on the same VPC, and you can have a very high bandwidth connection, not a problem. But if you're having a big fat pipe between the user on premises and this machine configuration you might have in a VPC, if that pipe is fat, like fat pipe, then this pipe is also expensive pipe. And that is something to avoid. People will try to optimize on this size. So the quantity of data flowing, how much and how frequently, the quantity of data, frequency of data, latency of transaction, that you have to understand and study. And at some point, you need to think about these quantity of data in terms of just size of the data itself, frequency, latency. These characteristics you have to study in terms of how that particular application that you're talking about will perform in a simulation if you take the application and as a pilot, put it out. So you take a pilot project, identify a segment of users out of your total number of users you might have, identify a portion. And this is our test user base. So test user base. And so you create a pilot and you identify these users as your test people and have them connect to, so whatever you have on premises, you keep it as is. However, you create a separate isolated pilot, and you assign these test users to that pilot and measure. Measure what? Measure the user's happiness. Are they happy with the performance? Measure how much are you spending in terms of money on a pilot, and understand how do these things translate to cost savings on a pilot, and extrapolate that to a scenario where you imagine that the whole thing goes away. Not a pilot anymore, but what would it be from a cost savings perspective if you have the whole thing move away to the cloud, to a VPC, and understand what would that mean from a cost saving perspective, from a user's happiness perspective, from the overall application's performance perspective, from the perspective of quantity of data being transmitted from your premises over to the cloud, which may be away. Sometimes the cloud can be local. Like, a cloud can be local because it is a private cloud. But in those scenarios, if the cloud is local to you, it is in your building, in that scenario, those performance issues do not come into play. But then most companies don't typically talk about a local private cloud unless they're really large, like Boeing, for example. They have a private cloud and they are playing with public cloud, and all those scenarios apply. Now, having understood these aspects, the essential bottom line summary is you do not take an example application and do this crude method of just taking the thing and putting it out there in a virtual machine and just live with it. That is a bad way of doing it. So don't try that. Instead, think about a segment of your on-premises users. You have on-premises, you carve out a segment of users. These are the test users, and you assign them a small little pilot and measure. The measurement aspect is super important, because only if you measure that you will know whether you succeeded or not. And so those measurement metrics can apply to the application itself as to what that application is. How will you measure the happiness of the user? How will you measure the performance of the application between the test base and the pilot that may be happening outside in the VPC? And compare that and extrapolate the information that you will gather from the pilot to a scenario where you will take the whole thing out and put that in a VPC, while at the same time also understanding, with the help of the application developers themselves, are there certain characteristics that we can change, modify in the context where the application itself needs to be updated to handle data differently, so that the width of the pipe that we might have between premises and VPC, maybe we can accommodate the transactions that flow to modify the app, redesign the app or certain portions of the app to better accommodate the distance that you will potentially have between a user and the cloud. That geographical separation we have to account for to the extent feasible in the application redesign. So there is, depending on the application, there may be some aspects of the application that will accommodate a redesign that may be appropriate. Again, it boils down to which application are we talking about. An example.
Really,
yes, go ahead.
Really, that is part of the entire migration process, is to go through that evaluation.
Yes. So if you recall Outlook, right, long time ago, I'm just picking up Patrick's example. Outlook back in 2006 and 2007 timeframe used to freeze on me, right, really bad. And so we are connecting to the Microsoft Exchange, and Outlook will freeze. It will just die. And on top of that, we had this stupid thing called Vista, right? That used to kill everybody. And so you start Vista, start Outlook, and the whole thing dies. I mean, it will take, after 10 minutes, you have the Outlook client will respond. And that was primarily because of the fact that, people using Outlook, the app, are connecting to some machine out there, which is the Exchange. And this application needed to be redesigned in a fashion that it became smarter over the years, where now Outlook client doesn't hold up the CPU for any pending traffic that you might expect to come back from Exchange. So Outlook doesn't freeze anymore. It will say, okay, I understand that the Exchange server is not responding to me. I should go ahead and listen to my user. And if the user wants to minimize Outlook, we should let the user minimize Outlook and not freeze on him. That change in the application, in the networking of the application between Outlook itself and Exchange, was one simple change that people did. In a updated version of Outlook with 2013, it became much nicer. And today, we don't have that problem at all. But if you recall, this is the scenario we used to have it. It was bad. And in the bottom line is you change the application itself to accommodate this transaction. You get the point. Do you remember this scenario I'm talking about? Vista and Outlook freezes. Do you recall?
Well, Vista was kind of a disaster all by itself, but
yes.
Yeah.
yes.
Was it just polling instead of being asynchronous?
Yeah, it was locking up the whole machine for until the Exchange server will respond. I will not listen to your mouse movements.
Yeah, it
Huh?
sounds like it was like polling or something,
Yeah,
waiting
some
for it.
crazy lock. So it was there. We complained a whole lot to everybody, and I used to be in the Link team at that time. It's called Office Communicator. Uh, it used to be called Office Communicator those days. If you know what this thing is called Link.
Yes.
Oh yes, good old Link.
Yes.
So that was part of the Lotus communicator, really?
No. Lotus, no, not at all. Link is Microsoft. Link is
Okay,
yeah.
okay, yeah, yeah,
Link
okay.
is now
Business.
Skype for business, and so this is
Skype for
my
business. Yeah.
yeah. Link is my puppy, and so here you have the patent on which you detect physical presence, right? You see that? This idea of technique of detecting physical presence is a patent that I have assigned to Microsoft.
Yeah, no, and I've used Link a lot, and it's very cool. I mean, it's really nice. So
Yes.
yeah.
So this aspect of patent basically is the one that is responsible for detection of presence. Whether you are green colored or red colored or those colored bubbles that show, you remember? They're still in the Office suite. Yellow, I'm
Oh
busy,
yeah,
I'm away, or
yeah. That's it.
appear away, if you remember. Appear away.
Yep, they have it in. They have that integrated into Outlook now.
Right. So those are basically this patent that you were looking at, which is 2007 back then. So
Yeah, I actually wrote an application that used it for all our user base and HPC, and it would load it on one page, but I guess there's like some kind of it would wait 5 seconds per call, so it would just take too long to use it in a single threaded application job using JavaScript on the client side, so I just kind of abandoned it.
so those days it was called Office Communicator, and then it renamed as Link, and now the new name is Skype for business. They could not find a shorter name apparently. So Link was good enough as a short name, but then they had to expand it. Thank goodness they don't have Skype for Business Professional Edition 2017 update, roll up update 3. You know what I'm talking about. Do you understand the joke?
Yeah.
Yeah, Microsoft people will get it. So the idea is in terms of naming of a product. That's what I was joking about. So let's uh, ask you this question. Do you get this at least a short answer to migration issues? Migration issues involve studying the application, studying the user, studying the traffic, and understanding on a small pilot basis what does it take to actually take it away to the cloud, and then measure, come back, do the homework, understand what would it need to change to modify the app itself to accommodate the issues that we saw, and then understanding the overall implications of taking the whole thing away to the cloud and then taking it. I mean, that's what it boils down to.
So
If
two
you
Yeah,
questions.
Yes.
and that means that when a customer asks you, can I migrate my internal on-premise application to the cloud, your response is what you just said.
Yes,
We have to evaluate
the
it.
answer is yes, it is technically possible. Let us evaluate and understand what would it take to do this transition, the migration, without burdening too much on your customer experience, on your bottom line. Like we will have to evaluate on a step by step. We'll start small, take a small pilot, try it out, see how it succeeds, see what does it mean, see what it does it mean to your users, to your customers, to your bottom line, to your business, to your cost structure, and also to your application developers. There will be a cost to them because they will have to change certain things based on what we find. And so that finding will bring back, discuss with the app developers, help them understand, help them modify, and then that is also a cost. Changing is a cost. So that all these aspects together will constitute a migration. Migration is not just taking your thing and move it out, and that doesn't mean migration. It's the crude way of doing it. Don't do that. So crude is not the way to go. Technically you can, but crude is basically asking one of your users to go on travel and connect through a VPN connection back to the corporate. So he's the traveling user, and when he travels, this whole data center you might have on premises is kind of sort of like a cloud to him because he is away. And so, and you've seen VPN traveling users complain all the time. At least they used to. And so that's what we will essentially do when we analyze and study for a given situation on a pilot basis, understand what it means, take the learnings, apply them, and then do the whole thing. It basically, the short answer is, can I migrate? The answer is, it depends, right? Like as usual. So we'll study, we'll understand, and we'll do it.
Two questions, Nilesh.
Yes,
So
please.
when you do the linear extrapolation, you do your pilot, you measured your factors, cost and user experience, etc. So now you're going to do your linear, your extrapolation, I'm sorry. Is it generally linear as you bring in the larger population, the whole migration, or can there be factors that are amplified if you add the whole population in, like amplified exponentially, not just linear? The issues that may pop up,
Yeah.
or is this straight linear extrapolation? And the second question I have is, when you phase them in, do you phase them in, or do you bring everybody to the party? You made your modifications now post migration, post pilot, and then you migrate everyone to the party at one time, or do you gradually phase them in by department? So those are the two questions I have. Sorry.
So the answer is, it is not necessarily linear. And the second answer is, yes, do it gradual. Don't rush.
That was easy.
Yep.
Well, you're going to run you would want to run some type of load test, right, against the environment to make sure it can handle
Yes.
different types of loads throughout, the workday, the night, whatever it is. And that should keep things in perspective, I would think, right?
So keep measuring as you add more. So as you grow the pilot to a bigger pilot, you keep measuring and understand how it is changing, because that will answer your first question. Is it linear? Right? So you do a pilot P1, you do a bigger pilot P2 and see what happens, and do another pilot P3 and see what happens. That will tell you whether it is linear or not.
Because it sounds a lot like test-driven development.
Oh, yes.
Test-driven
Yes, exactly.
like that.
Exactly. You always do test and measure. Test and measure. That's how life is. I mean, if you don't measure, you're screwed. If you don't measure, you don't know what you're doing. Practically, right? You have no idea what you're doing because you're not measuring. So you're just doing it. It's like drunk driving.
The end customer, and the end customer has to understand this is all a cost associated with the migration. So before you get to any migration, this is part of the cost to do that. So yeah.
Yep. Overall, the whole thing is a cost. Understanding in multiple pilots, increasingly bigger size will tell you linearity, and keep measuring. That's the only way to succeed. Because if you don't measure, it is like drunk driving. You don't know what you're doing. So you will have no idea where you're headed, and you will just go without figuring out what you wanted to do to begin with. And that's basically messed up.
Hey Nilesh,
Yes.
given the level of interest, would you think we should do the migration of a sample app maybe and just do that test drive here? What do you think?
Bring your sample. We'll do it. Okay, bring your sample. We'll do it. I'll illustrate that. Bring your whatever you have an idea. Bring it up, and we will either one-on-one or sometime in the session, after the session, extra session, whatever it takes. Bring an idea. Okay. Let's play it. Open-ended. I don't limit myself to one given example. Just bring your idea, and we'll do that idea. So open-ended. Bring up an example. Let's work through it.
Sounds good.
Cool. Yeah. Okay. So that was migration. So that was about. Go ahead. Another question. Yes.
Nilesh, I do have a question.
Yes.
So this is assuming that the migration is happening of an in-house or some enterprise application. But these days, the migration is also happening because there is a SaaS or a software as a service already available for something that an enterprise might be doing. For instance, Outlook. You know, a lot of Outlook has been deployed on-premise. Now everybody is trying to move it to a cloud implementation. Like partners used to do it for Microsoft Office, and now, do you have any thoughts about that? Like, it's not about changing the application itself because the application is already available as SaaS, but the migration has to happen.
Right. So that migration has a different characteristic in some sense, and I'll tell you an example of that. Imagine, back to my favorite example, TurboTax, right? TurboTax software for 2004. I've been using since that time, right? Actually, even before. Probably I've been using TurboTax since 1999. So that software used to be a desktop software. It is still a desktop software, by the way. And so I have my files that are backed up from those years backed up. So can I take this desktop application in the year, say 2006? I filed my taxes, and then they are in a desktop application. I have them backed up in some location. Now this year, 2007, I want to use the TurboTax for the web, which is basically there is no desktop application. No desktop. So can I do it? The answer is yes, you can, provided you can reuse the backup file from a previous year and import it to the new year, 2007, so that all your data that you have used in the past and all your depreciation, amortization, this and that, and deductions and all the things that are related to a tax is available to you in the new year without you having to type the whole thing again. That becomes really boring, right? If you want to type the whole thing again and again, that becomes boring. It is very expensive, very time consuming if you do it at a large scale. So
it's error prone too.
Yeah, it's error prone also. So you're basically talking about migration between something like a desktop app to a browser based app. That's one scenario. Another scenario was you have an Exchange server in your data center, and you decide that, you know what, my enterprise assurance license is kind of, something that I want to change away to go to Office 365, and I want to give a different mode of dealing with my Exchange because I don't want to use it anymore. I'm basically trying to kill EA. I don't want to have it. I'll rather pay $6 per user per month and just use this service that Microsoft provides. And that's a valid scenario. The people tend to do that because they don't want to maintain your Exchange server. They don't want to get into the licensing and the maintenance of the server. So you are now basically translating a data structure you have here and in migrating that data structure itself, the whole database itself, Exchange database, over to this. And there are very, very detailed documentation available from Office 365 on how to do that. And you just follow along and you can basically export the database that you have in your Exchange data servers over to Office 365. And that's a migration path. Now, from a performance perspective, yes, there will be problems. People will complain. People will complain for a variety of reasons. For example, people in the headquarters where the data center is, they will say, you know what, this new Outlook, I don't like it. It is slow. And they are right. There is geographic distance between the data center that is in the headquarters and the Office cloud, which is in Redmond or somewhere. I don't know where it is. Maybe it's under the ocean. We don't know where it is, right? So they will put wherever they feel like. Office will put, Office 365 will put the users in the corresponding Exchange mailboxes wherever they feel like. They will not tell you where they are putting it. In some, they call it pods in Microsoft. So in some random pod, you will have it and that pod will maintain your user data, and that's where you will connect to. So the users in your HQ, which were used to connecting locally to a data center to the Exchange server, are now complaining that they have to now go to the pod where this office is set up for these users in the HQ. They will be unhappy a little bit. However, people who are traveling, or maybe those who use iPhones, they will be happy in that saying, you know what, my iPhone, when I was outside my office, never connected to my data center Exchange because there was some firewall issue or some routing issue, and my network was causing problems with a variety of things, right? So my iPhones used to work with Exchange only when I'm in the company, but not outside. But now I have this Office 365 and I'm able to connect to it just fine. So I am a happy puppy. And so that user might find that they are happy. And so this happiness or sadness will vary depending on where the user actually, how they are using it. At the same time, this network administrator who is basically taking the data from this Exchange location and porting it over to Office will have a decent amount of hard time porting. Let's see what it takes. Porting Exchange to Office 365. Let's see what documentation comes up. So there we have migration tool. There are third-party companies. There are code2.com. There is a tool available from some random company we don't care about. Let's see if there is a Microsoft documentation, but apparently not, which is kind of crazy. But that's how Microsoft is. They will never do what the people will like to do. And yes, see, we cannot find it. In one shot, I should be able to see how to migrate my Exchange to Office 365. But then as an Exchange administrator, I am stuck. I cannot do a simple Google search and find out. I have to go and rely on these third-party guys to make it for me. And so here is Exchange to Office migration. And you can call this learn more and then talk to them, and they'll do it for you or pay them money or something like that. And at the bottom line is that they have some service that they are selling you. They're probably giving it to you for free to start with, but essentially there has to be some documentation that I cannot find easily that exists in Microsoft that will let you do the same thing without having to invite this code2 guys, this company. There has to be some documentation. Somebody must have written it, but it's just that it is hard to find. And that is classic Microsoft. I'm not complaining, but that's how it is, like fact of life. So now I don't know how to find it. That's a cost, right? My administrator who is responsible for migrating my Exchange over to Office 365 will struggle to find. He'll make some calls and figure out how to do it. Eventually, the migration will happen. When the migration is happening, your users will complain that, my data is not accessible, my mailbox is not accessible, I have some downtime, so what do I do now? How do I arrange a meeting? How do I see my emails? So those issues will cause some downtime, will cause more complaints. So migration from one setup to a similar setup is, migration from one setup like this, Exchange server, to Office 365 is less painful, let's call it that way, compared to a full-blown application running on some machine and take that to a VPC. That is very painful, comparatively speaking. So this is less painful, this is more painful. That's how I look at it. The pain exists, it doesn't go away, it's always there. Then there is this cross migration scenario where you have an Exchange server, but you don't like to spend $6 per user per month because that is expensive. And I have 500,000 or 50,000 users. That multiplied by 6 is a monthly cost, and that's ouch. So what do I do now? And by the way, I happen to be a university. So I might go and talk to Microsoft if they can give me a discount. But then you know what? Microsoft says, let's see what they give. EDU discount Office 365. So there is an education plan, and it is kind of sort of not free. Is it free? I don't know, but we'll find out. So I have 50,000 users in my university. How do I get? So there's a free trial available, and then it is available for 30 days, and then you have to pay for it. Man. So instead, what I find is that I have this Google education that is like totally free. So why not take it? So here we have a good solution for the school, like what I gave you, Google app for education. This is a competing solution from Google, competes with what our scenario, exactly this scenario. Take your exchange, but you know what? Don't go here. Instead, go here to Google Apps. And this migration is also painful. So migration exists. The fact that you have to migrate makes it pain, it causes pain. But you can take your exchange on your premises and say, you know what, bye-bye exchange, I want to go to Google. And that is a valid possible scenario. You can go google.com/A, which is the Google Apps services, or you can take this to Office 365. So if you're an educational institution, you're very likely to go this direction just because it is free. And University of Michigan has taken on like 70,000 users on google.com education, and they just migrated. There's big news about it. There's tons and tons of universities, they're all going that direction because it is free. And corporates find that this is more streamlined because it is basically from the same vendor. Streamlined. So Boeing company is not going to go that direction. Probably not. They are going to go this direction because they have Exchange, and I'm pretty sure they are on Office 365 already. I'm guessing. I don't know. But I'm betting money that you are already migrated to Office 365 for your entire organization. I'm just betting. I have no idea, but I'm just saying.
Yeah, it turns out there's also security issues. That's where Microsoft is really focused, is making sure that the email is very secure. And they win against Google because of that.
So can you elaborate more exactly on what do you mean by security? What security are we talking about?
Well, the security, like, is an example with companies. Government. And this was something that I saw happen, and I couldn't believe it. And they were really... So Microsoft and Google both went after the Army. And the Army said, they always look at what is the cheapest solution. And Google was the cheapest solution. And Google got the business. And I remember thinking about that when I heard that happen. I said, well, of course Google's going to get the business because they're going to be the low cost provider. And then the Army went back to Google and said, oh, this is great, but we need this kind of security. We need to be able to have, to know that all the information that's on the Google servers is actually secure. We need to know that. It has to be ITAR. And Google said, well, we don't do ITAR. And they said, but we have to have ITAR. And they said, we don't.
Yeah.
And then all of a sudden, voila, Microsoft now has the Army. So it was really crazy.
Yes, you're right. And that is a good example. So certain characteristics that you have to have for a legal mandate, like a government mandate, regulatory scenario. Certain companies, such as here, are focused primarily on serving that mandate very, very precisely. And they will ask for something, and then Microsoft will go diligently create that thing and win the business back. And this happens all the time. And so the contrary story you will hear if you go talk to Google and have a Google person on this Cloud Genius session. He will or she will say something radically different. I know you have experience with Microsoft, specifically with Exchange, so you know the details behind it. But a very flip of the story can also be heard from a Google employee telling us what their story of security is, and they might actually question, just like I began you questioning, what do you mean by security? What do you mean Google is not secure? Are you kidding? And you gave a very concrete example, and that's a valid one. It's a requirement from a government mandate, and that's what Microsoft made sure that they are winning because they made sure to implement it. I will show you a contrary example now where this solution set actually lags behind this solution set. And it is also in the context of email security. And I can illustrate that very, very quickly. The aspect is known as, let me get the name right. So here, you see this thing called signed by gmail.com. This scenario is not implemented by Office 365 yet. This thing is called DKIM. And it is DKIM. Let us see if Office has it supporting now. And let's read. And so the discussion is, does Office 365 support DKIM? These two features are currently being rolled out and will be fully deployed by the end of the first quarter of 2015. And so at that time, when I first saw it, it was not there. This particular feature of DKIM was not implemented. Let us go actually go to Office 365 and see what they have implemented, whether they have DKIM or not. So I'm going to my Office 365 account, signing in, and okay, sign out. And I want to go to Office 365, and that's another problem with, I cannot find the login place. There it is, Office portal, and sign in, not right now. Go update my password, and let us see if that DKIM thing is supported now. It'll tell us. Okay, no thanks.
Yeah, I was gonna say, even Microsoft's notorious for, things being hard to find. Like if you want to write Python code or Java code, it's so easy to use the API and just Google what you want to see. If you want to write C# code, you got to dig to find,
I know.
The right methods and things for APIs. It's such a pain.
Yeah, and even just like this, I'm trying to access my dashboard on Office 365, and apparently I cannot. See that portal.office.com, and I signed in, and I see the dashboard, and I say no thanks to this thing, no thanks, and then okay, there it is. So now I have my setup services. Let us see my DKIM settings if that's available, but I doubt it. I doubt that they have implemented it yet, because the last time I saw it was not there. However, let us see. Start the setup. Okay. No. So are you familiar with this Office 365 setup, or is this the first time you're looking at? Do you want us to go deeper in this scenario, or you know what we are doing already? Just a quick question. If you have seen Office 365 backend before, that's great. But otherwise, I will show you from the beginning as to what am I doing. So I have a domain already mapped to Office 365. If you haven't seen it, and if you're interested, I can show you a little bit detail. If you are interested in setting up, yes.
It's a bit after the top of the hour, maybe 5 minutes, and then come back and we can go through that.
I think that's a great idea. So it is 8:13 right now. I'm going to add 5 minutes to it, and so make it 8:18. And let us get together again. We'll continue our discussion at 8:18. And we'll take a short break. And again, during the break, no tech talks. That's what I have learned.
Well,
So that's the decision, right? This group decided no tech talk at all during the break, so we just shut up, talk about football or something else.
let's talk about business. Let's talk about business.
Fair enough.
So, as a consultant, I will have customers come to me and ask me to do these things. And so it behooves us to know, what's going on out there relative to migrations, relative to 365, relative to Google. I mean, all that, isn't it? Neelish?
Yes, yes. So so migration essentially is a business topic. Like
Yeah.
it is a business. At the end of the day, everything is a business decision, right? Whether you do it in technology or not. So migration by its nature is hurting the bottom line. It might hurt the bottom line. It might actually save the bottom line long run, but in the immediate short term, people are just afraid of one thing, which is change. They don't want to change. And that's why people show this resistance to change. And so they don't want to, hey, everything is working fine. Why do I have to mess with it?
Well, exactly. But I mean, you look at a company, and if you don't change, particularly software, if you're not updating it and you're not acquiring the latest and greatest, then all of a sudden one day you can't migrate to anything.
Yeah.
The stuff that you have doesn't really work. It's susceptible to hackers and all that kind of stuff, and all of a sudden you're in trouble.
Yep.
So, I mean, as part of running an IT operation, you've really got to be looking at all this stuff and where you're going with your technology.
Yep. A change is necessary evil. You just have to do it.
Yeah, yeah. And then if you can move it to the cloud, you can save yourself just tons of money of managing your own on-premise operation and all that. So, yeah.
I was say there's like it's a balancing act, because a lot of times, as far as upgrading software and things like that, you want to have backwards compatibility for a certain amount of time, because at least from my experiences, you'll have engineers who are using codes that are, even up to a decade old, but nobody's updated any of them. But it's critical to get the job done. So it's like, all right, how are you gonna upgrade? How are you gonna upgrade all your systems, but still support these old codes at the same time? And that's where actually I've looked at things like Docker is kind of cool, because you can launch images of different OS instances, and they can use things like that. But anyway, but we'll learn about that sooner.
Yeah, no, it's cool stuff.
Okay.
I talked to one company who was using AWS, Azure, and Google as cloud services, all in the same operation. And I was trying to be nice. I said, so why do you do this? They say, well, because different legacy applications work better in these different environments. So they were supporting Office 365 and like 2 or 3 legacy programs that were running under AWS and under Google Cloud. And they were supporting them all. And it was still, they considered it a cheap solution rather than having to run them internally. I thought that was crazy, but I guess not.
Okay, so we are at 8:18. Let's continue. So what I want to focus on some of the aspects between these two toolkits we have, which is kind of sort of, I would call them under the collaboration umbrella, collaboration, office communication collaboration umbrella. The umbrella solutions, there are 2 major players, Google and Office 365. They have, both of them, very, very similar solution sets. Yes, some have some specific capability, like you mentioned, ITAR, and some other have some exotic capability like DKIM to understand whether the messages are being sent signed or not. And so both of them are corner situations. Mainstream, the scenario is very, very similar. You have a document called Google Doc. You have a document called Word Doc. Excel spreadsheets here. They don't call it Excel, but they call it spreadsheet. They have Excel as spreadsheets here. And PowerPoint. They don't call it PowerPoint here, but the same thing is available here. So basically, you have documentation, creation, collaboration, communication, link. They have here in Office side, they have the link support. In Google side, they have Google Hangouts, and setting up Hangouts and link is equally easy or equally difficult. In fact, if you go look at our Slack chat, and I can start a Hangout by typing HANGOUT, enter. And there we have a new Hangout. So it was so easy because I have integrated Hangouts into the Slack application. So now you have a link. Don't click on it right now, but don't click on the link because it will start a new Hangout session with me. So don't do that. But I'm just saying that if you are looking at a message popping up in the Badal group, are you seeing something popping up in Badal saying start a new Hangout in this channel?
No, I'm not seeing anything.
Okay. So what I just did was basically started a Google Hangout session that looks like this. And this will start and invite people to join this online meeting. And this happens and it will send a message out to all of you as soon as I invite you. That's what you're looking at on my screen. So it's an integration between what I currently have in Slack with Google Hangout. And that's the scenario that you're looking at. From a communication standpoint, that's the application. And some of you already have used Link, which is these days called Skype for Business. Skype.
What channel did you put the Hangout in? The Badal group?
I think I did put a Badal group, but then it did not pop up for some reason. So we'll investigate later.
Okay.
So the focus right now is what I'm trying to suggest to you guys is that this idea, the Uber idea of collaboration and communication, available from two different vendors, is very, very similar in its nature. You have documents, you have communication, you have calendar sharing, you have things like file sharing, like in Skype for Business, in Office 365, you have the OneDrive for Business, and here you have the Google Drive for some price. I think 1 terabyte or something is given. Here OneDrive is also 1 terabyte given to users. And so most users will get this 1 terabyte size drive in both sides. So it's again very similar. All you need to really focus on, and unless you are an EDU, educational institution, then this is unlimited terabytes, which is a different game. So that's what all of us have it, by the way, as you know. So I'm not sure if everybody has access to the login information or not, but please look up the Badal group and you will find your login password for this side of the equation, this side. We have a Cloud Genius account for each one of us that we can use the Google services forever until Google goes out of business. So that's the scenario. Having continued in this discussion chain, the scenario that you require is that you need to have a domain name. And that domain name has to be able to be hooked up to one of these services. Either you go to Google side or Office side. And so either you go to Google or go to Office. And sometimes you can have parts of both companies' services apply to the same domain. You can actually use it that way if you want to, like some companies attempt to, but you don't have to. Most companies will take their pick and go either Google or go the Microsoft route and stick to that game until they find that they are unhappy, in which case they will migrate away, like Army going to Google first and then coming back here. I have seen the other way around also. So both scenarios have occurred, and all you basically do is take your domain, and if you have a domain, by the way, that becomes a good exercise to try if you're interested. This is an optional exercise, very, very trivial, is to map your domain, and you can do this for free for 30 days. Both these companies give you this choice of trying out these services. So you can try on google.com/a, that's the address. And on the Office side, I think the address is different. It's not, let's see if I can find it quickly. I think I have it in the list of services here. So that's the link. So here is the trial link where you can get a trial link for Office 365 available to you in Slack chat. So here we go, paste. This is one link, and the other link is google.com/a. So these two companies offer you a solution for 30 days for free usage on their properties, and the Google Apps begins in this location. Office 365 begins in this location. Both of them will give you a plan that you can make use of for free trial that you can identify here and basically experiment with what does it take to take your company, your business, your domain away from your own servers, managing your document collaboration and communication challenges in email and video, audio, link, Hangout, Skype style communication collaboration activities, and take that business over to either Google or Microsoft and try that out for a period of 30 days for free. The trial is available on both platforms. And so that becomes a good exercise if you're interested in playing it out. What does it take to actually make that migration happen? There are some, I think most of the flow, once you start the trial, is very, very intuitive. And if you get stuck, you can always come back on Slack and chat with me. If you're doing that exercise, I suggest give it a shot. It's a totally easy and optional exercise. If you're not familiar with what these tools and services are from these two companies, I suggest you try both of them one at a time for 30 days and figure out what those tools are and how do they compare contrast. You should be able to do that comfortably. In addition to this, what I want to ask you is on the topic of software as a service. Is there anything else that you may be interested in discussing? I would like to know, because otherwise I would like to switch the topic over to platform as a service discussion. And I would like to begin discussing Git. Once we have that understood, we'll use it and then switch over to writing a small application and then deploying it on some platform as a service, understand what that takes, and then to the next bigger step, which is, you know what, this platform as a service that somebody else gives us, there's someone else is maintaining the pass and they're just giving it to us for usage so we can run our app here, and that's great. But what if I want to run my own platform as a service on top of some infrastructure available, and then I write my app here? That exercise is also available. It's a very involved exercise, and you have to be really, really diligent to follow along to succeed. It looks short, but I'll show it to you what I'm talking about here. Hold on. Let me go there. So the exercise that we have is already written down. It is deceptive in that it might look easy. It might look trivial, but unless you are diligent, it is not going to work. And the exercise is right there. It's coming up in Slack chat. And that is, just a page full of something, right? That's it. But then this is not very easy to read and actually do. So I will do it with you and help you understand. But I require that you absolutely pay attention and be super diligent on what exactly we are doing, because without which getting a platform as a service to run on top of infrastructure as a service is a non-trivial game. So I'm just cautioning you. It's a non-trivial exercise. It looks only one page, but it is non-trivial. So having said that, I will do it with you. So that's the game plan for today and the next day that we have, is to be able to first of all ask you this question. Is there anything else that you want us to cover on SaaS before I switch topics? That's the first question. And then we'll follow along. So what do you think?
Let's move on. I'd like to go to PaaS.
Okay. So before we jump to PaaS, I would like to make sure everybody understands what Git is and makes use of it. It is, again, requires terminal usage, requires diligence and understanding. So I will begin that piece. And then once we have that in our command and control, then we will switch to writing an application. And that is also written down very, very clearly in a location somewhere here. Okay, where is that? PaaS, hands-on. So it begins in this location. That's the ready-made PaaS exercise. That's the ready-made here. And the other one was our own PaaS. So you read that. And let us begin with Git. So Git, there is a writing available for you to read that is called Let Us Git It Right. Module number 14, Git It Right. It's deliberately misspelled. And you can read, it's only one module, but it's fairly long, and it is this one. So read that one, but not right now, because reading itself is quite a challenge. It's quite a challenge, actually, if you read this. So I'm not making you read, but I do want you to read later. Don't read right now. Right now, what I intend to do is to help you understand Git in the fastest way possible, like really, really quick. And I want you to really get it. And I can accomplish that by showing you examples in my way of discussing. So I will do that. First of all, some background. What the heck is Git and why do I care? That's the background. So that's what we'll discuss next. I will get a sheet of paper and start talking about Git. Git is a bad word. The official definition of Git is, let's see what Git means. I think I discussed this with you guys. Git means stupid or something like that. So let's see what Git means. So the manual for Git is, it's a stupid content tracker. That's the definition. Formal definition is this. The creator of Git is Linus Torvalds. You probably know him, at least by name. This way, Torvalds. This guy who created Linux also wrote Git. Why did he write Git? Because he was frustrated with how the current generation of source code control systems, source code management, that's what it is about. Managing source code. Now it has been extended to managing documents and files and large objects. And so there is large scale, large object Git. There is an extension of this. It was initially for source code management. It has been expanded to cover a variety of things, so including large objects and variety of usage scenarios. But right now, our focus is to understand the core of Git, which is to manage change. It is about change management. Whatever you're writing, whatever you're creating, and you're creating typically as a team. So you want to write something and you want to understand who changed what and whether that change is in line with the overall goal or not, and whether that change is good or not, and whether that change should be kept or not. Should we keep the change or we reject the change, right? Those decisions. People in a team setting will be multiple people. They will all operate on their own and they will make some changes to the overall project. And you will put this project inside what is known as a repository. What is a project? Again, so that's clarity. Project is basically a directory. So it's a folder. Now, where does the directory live? on your laptop, and you make changes to it. Delta, this is delta. You make a change, and then you know what, these other people, let's imagine a team of two people, A and B. So this guy has a laptop, this guy has a laptop. So two laptops, they have a folder here, and this guy has a folder here. So this is basically, he makes changes here and he makes changes here. And somehow we need to find a way to synchronize these guys. And he may be in China, and this guy may be in Zimbabwe, who knows, right? So there are two different people on the same team, sitting geographically separate on different time zones. They may not talk to each other, but eventually they will. But the challenge is we have to make sure that the folder here and the folder here is eventually synchronized. And the changes he's making and the changes this guy is making are digested. When I say digested, I mean appropriately kept or rejected. Either you keep the change or you reject the change. So that you have to do. That's the digestion process. Either you keep it or you reject it. But a change is a change. You have to make sure that it's understood, and then you keep or reject. And that eventual syncing has to happen. So that's the scenario. That's what we really want to do. We have people randomly sitting globally wherever they are. They're working on a common goal. The goal is for the team to prepare something. To prepare what? Is a project. A project is basically a folder, a directory. And they will create items in the directory, inside the directory, which might look like whatever it looks like a typical folder, right? Let me open up a folder for you so you will get what I'm talking about. So here we go. Here is a folder opening up, and I'm going to open this folder in a editor. Yes, I just said open a folder in the editor, which is kind of strange if you're not used to the idea, but let me open a folder in editor. You typically open a file in editor, but I opened a folder in the Atom editor, and I will show it to you now. It's coming up. So here I have opened up some folder called Cloud Genius. It is way too big, so it's almost my entirety of my laptop. So I should close it. Maybe open a smaller folder instead. So here we go, smaller folder, and open it in the editor. So here we have a folder that you can see on the left side is the folder structure. It has two things. One of them is another folder, and one of them is a file. That's it. That's the content of that folder. So that's what I'm saying when I say edit a folder. I actually mean opening that folder in the Atom editor to see the visually what do I have in the file. I can just click on the file to see the content, or maybe I can expand the folder to see the content of the folder inside, and then identify what this thing is, like that. So that's what you're looking at, a folder structure. Now, people can collaborate and create content in that folder. If I open the folder itself, that will look something like this. You see that the file that you saw before shows up. The file that you did not see was a hidden folder, so it's not visible here, but it exists. You can see it. It's the folder called .vagrant. Anything with a dot is not visible. So now that's the idea of a folder structure that you are looking at in the editor, which I'm going to close. And this time I'm going to create a new folder that I want to share with you, all of you. And I will do that. Now, in order to share that folder with you so that you also have a copy, we would like to have this entire team that we have right now. Each one of us, all of us, let's label ourselves ABC or just have our names. So we have like 13 people right now in the team, in this team right now. Each one of us needs to get a copy of the folder that I am going to create. And our goal that we have, 13 people, our goal is for each one of us to create files. in that folder. My idea would be that this is Nilesh, let's say. So Nilesh, his task is to create 2 files. One of them is called a.txt and the other file is b.txt. That's my task. That's the assignment I got. And similarly, A through number 13, person number 13 on this call, on this meeting, will have the task of creating c.txt and d.txt, and like that all the way. 13 multiplied by 2 will go to y.txt and z.txt, and I will just assign those specific tasks to each and every one of us, and I'll do that, and that will constitute a folder containing 26 files labeled A, B, C, Z, .txt. That's the goal, right? It's our goal. Our goal as a team is to create this folder structure. That is our project, right? So as a leader, let me begin by creating an empty folder, right? So here we go. In my editor, in the terminal, I'm going to clear my screen and create a folder, mkdir. I'll call this Badal. There we go. So I have created a folder, right? You saw it, but you don't have it yet. Awesome. Now I will go inside. I hope the font is not too big or not too small. If it is so, please tell me. I'm just adjusting it a little bit so you can see it properly. Okay, I went inside. I think this might confuse you, so I want to quit and go back to the Cloud Genius workstation so that we are all on the same page and don't want to confuse anybody. So I'm starting the workstation so that you also have the same exact thing like we are doing, and we are all okay on the same page basically. So it'll all look the same to everybody. Otherwise my Mac kind of looks different, which is not what I want to show you. Nothing that I want to hide it, but I just don't want to confuse anybody. It looks different though. I just saw it, so I just shut it down. Now I'm back in my workstation, Cloud Genius workstation. I'm going to do the same thing exactly the way I was talking about, and it's coming up. Here, terminal, click, create a folder. mkdir badal. There we go. Go inside. I got there. Now you're looking at the folder that I have. I can open that folder in the editor like this, and you can see that the Atom editor opens up with a folder containing nothing. Awesome. Now what? I'm going to construct a Git repository in this folder right now. I'm going to do that. How do I do that? The idea is we are putting discipline around what work we are going to do. And that discipline comes from the Git software. Git is installed already, and you have it on your workstation. What does that mean? Is that we are going to use Git now in association with this folder in which I am currently inside, as you can see from the name Badal. It shows you that I am inside the folder. Great. I'm going to now, and remember this, what I'm going to do is initialize Git repository in the folder like this. And I'll say Git, please initialize yourself. And I'll say right here, like right here in this location. So I'll say a dot. Git, please initialize yourself in this location. And so it did. Here we go. Now, before I go too much into a level of depth or level of coverage, I just want to understand how many of you have already used Git. Just Slack chat. If you used Git, say yes in Slack or speak, either way. No, just say yes. I don't need to know. I don't need to know the no answers, but yes is good. So yes, 1, 2.
Yes.
Yes, a little. Okay, good. So you understand. That's great. Good to know. So I will. There are some no's. Okay. Okay, good. So now you look at my screen. I'll focus on the key aspects for us to get to a point where we can get to the goal. Our goal, that you remember, is to create a folder with 26 files, A, B, C, D, E, F, G, H, all the way to Z, TXT extensions in that folder. That's what we would like to have in the Badal folder. That's our goal, and we'll do it collectively. And the task assignment will be, each one of us will create only 2 files that we have right there. So that's the goal. And we will do it in geographically distributed. I don't know which country you are in right now. I have no idea. But all we know is we are part of the same team. We communicate, we talk, we interact. But I don't need to know which location you are. I absolutely do not. That's the beauty of Git. Now let's get back to the machine. Here, in this location, you will see that it initialized an empty Git repository in that location. Initialized empty Git repo in this location. Let's see where it did. Badal followed by .git. So there is this hidden thing that created. So you can go list and you will not see it. This is hidden. Dot is hidden. If you go ls-la, you will see it right there. This was hidden. So you don't see it otherwise, unless you go A, which is all, and then it will show you that it has this empty Git repository, which is in this folder. And you will also notice the prompt changed like this. It was like this before. Now it says it is on the master branch. Now, having done this part, what I know is that I can see the thing in my Atom editor, and I see that there is this Git folder in which I have a ton of, I don't know what, honestly, but it is the metadata needed for Git to function, and it has basically the skeleton put in place, which has a head, a description, a configuration, some tags and tag and this and that and all that good stuff. I don't need to go inside the folder. That's the beauty of Git, is I don't need to go in here at all. I can safely leave this alone, don't delete it, because that's where Git lives. I can operate on my folder and don't have to worry about what this Git folder contains. Now, having said that, let us now make use of this Git. We have an empty Git right now, so we will create some files inside this folder right now. So you will see that the check mark here will change as soon as I create a file. You will see this check mark will change. I will create a file called a.txt right now. Touch a.txt. Enter. This action will create a file. And you see that the exclamation mark became took the place of a check mark. It basically shows that your folder is dirty. It contains a change. You just changed something. Now let us see the status of Git. Git status. It shows it is on the master branch, which is where we began to begin with. There are untracked files. I don't know what to do with this a.txt. Nothing added to commit, but untracked files present. And it is guiding us what to do with it. So we will do that action, but before I do that action, I would like to draw a diagram for you. The diagram looks like this. Or before a diagram, I would like to ask you this question. Have you seen Tinker Toys? You see what this thing is, right? You probably have seen it, played with it before when you were younger. I never had a chance, but I've seen it for my son growing up. So that's what a Tinker Toy is. And you look at, this is what a Git structure essentially is, by the way. This is what Git is. Now, you might laugh at me, and that's okay. But Git for 4 years and up is a beautiful YouTube video that basically describes So I will paste a link for you. And this YouTube video is awesome. I mean, my personal favorite. And this video describes Git using Tinkertoys. So that's the importance of Tinkertoys in this discussion. Now, having said that part, let me get to the point. The point is that Tinkertoys essentially are a representation of what is known as a graph or a directed graph. This is a computer science word, if you're not familiar with, from the graph theory. The idea is at every point along a structure in a graph, there is some state. And the state changes from A to B to C to another. And these are your Tinkertoys. These are also known as your Git references, if you will, or you associate them with a hash or a long sequence of characters. That's what a hash is. And so for every Tinkertoy, there is a state. And you can practically go from here to there or from there to here anytime you feel like, and not just from here to here also. Any direction you want to jump, you can jump. And when you jump, the state of that folder is restored to that point in time when it was captured. So these are basically what I call captures. So you capture something like a snapshot in a database. I know some of you are database people here. So you capture a snapshot of a database, and that's what becomes a state. So you can then go back to the state if you like, and you go forward from there if you like, and that's how you traverse. That's the idea. It's a traversal that's going to happen. We will do the traversal right now. But before we traverse, we have to take a capture, or also known as, in database language, a commit. So you have to take a commit and capture something in point in time so that we know for sure that this is the case of the state that we want to have on the Tinkertoy. So back here, it is telling us that we have something changed, and I can basically remove this exclamation altogether by deleting the a.txt file. So I will say remove a.txt, and then the exclamation goes away and I am all clean. Now if I go git status, it'll tell me it's all okay. There's nothing to do, nothing to commit, nothing to commit, because there is nothing to commit. I mean, literally nothing. The folder is empty right there. There's nothing in the folder. I'll touch the file again, create it one more time. There we go. And now we have the file right there, and the status changed again. This exclamation mark came back. Now if you say git status, it will show you that there is an untracked file. Something is dirty. Like in our sequence, we have the base, the foundation where we began, and it is empty. On top, we have a.txt, but we want to keep track of it, so we have to do a commit. Until we commit, this thing is dirty. After we commit, this thing is not dirty, because it is not empty, but it is a different Tinkertoy. And then here, we have a new state. This state is different from this state. This state was empty state. This state is the state having a file called a.txt. So it's a new state, different state. And let us do that, create that new state by committing something. So back here, it is suggesting to nothing added to commit, but untracked files present, use git track to track. Now this idea of commit happens in two stages. That those two stages are, if you want to commit, you want to first tell Git that, you know what, please start tracking this thing, this file. So track and then commit. The word track essentially is actually called add command. So when you add the file a.txt to Git, it will start tracking it. And then you can commit. And when you commit, you generate a new Tinkertoy, it generates a new state. Then you can jump between states, jump between Tinkertoys. Back here, our scenario, in order for us to complete our first commit, is to add, git add. So we have to add this file and tell Git to please track it. Use this command to track. So we will say git add a.txt, enter. So now if you say git status, it will show you a different message. It says still on the master branch, still on the initial commit, which is empty. Changes to be committed are new file. There is a new file. It did not know that this file was new until you track it. Now it knows that this is a tracked file. So it says, you know what? There is a new file. You want to cache, you want to commit it? You can. If you don't want to commit it, you can just remove, and that's okay. But right now our goal is to actually commit. So I will do that commit. The commit stage is a two-part command, which is, it goes like this: git commit. And for every commit message, there has to be, every commit, there has to be a message. So you have to have a message here with a -m option and a string followed by the message itself. That's how you can send, that's one way to send a message. This message basically is a reference to what the heck am I doing? That's what you write here. And so here I will say I added a.txt. That's the change I made. So that's my commit message. And if I don't type this -m option, you can still commit without it. So we'll see the both ways. First, without it. Right now, git commit. And it says, okay, then I'm going to commit. But then you should tell me what are you doing really, and that you should type it out in black and white in the window I opened for you in gedit. So please type something. And if I don't type anything, and I'll say no, and I quit, it will abort the commit. Aborting commit due to empty commit message. I did not type anything. I did not tell Git what the heck am I adding, why the heck am I adding. It aborted the commit operation and it basically came back to square one, which is git status, new file, present. I need to commit this file for serious. So I will have to commit this time, and it has to be done with a commit message. This, without the message, it does not commit. So you have to type this message that I have created this. It doesn't have to be this elaborate, but I'm just doing it for the sake of it. A.txt because Nilesh asked me to do so. That's my commit message. And this is how you collaborate and communicate across the team. What changes did I make in my Git repo? So I just made that change and I'm going to save it, and then I quit. And then now I have a commit, which is a new Tinkertoy and a new commit hash, which is different from the initial commit. This is a different commit now. And I can see the status. The status message is, I have created this a.txt because Nilesh asked me to do so. That's my message. And I will go check git status now. And you will see that it is on the master branch. And by the way, as soon as I committed, this exclamation mark went away to a check mark. Everything is good. Working directory is clean. It is not dirty. I have nothing to commit because all what I wanted to commit has already been committed, and we know it. So we can find out what was committed by looking at the log, which is git log. And here they are. There's only one commit, and that commit is this commit tag, commit hash, this long one, and it was done at this date and time by the person called this, and the message is, I have created this file because Nilesh asked me to do so. Great, quit. And now I have it protected. This a.txt is safe with me. How do I know? How do I know it is safe? Because I have managed to commit that in Git. What does that boil down to? It boils down to this. As long as I do not touch the .git folder, which by the way is invisible, I have the file a.txt, and if I happen to accidentally delete it, like for example, let me go this 50-50 here, so it's much better. Now I accidentally managed to delete the file. Boom. And it is gone. I am not worried because although my folder is empty, my Git has the commit, which means even though I am not clean anymore, I am dirty, I can bring my a.txt back by simply restoring to the previous commit, by resetting it. And here is what you do is you say git reset, and the command is laughable, but that's the command. And you can see that the file came back. On the left side, a.txt is back, and my git log is all okay, exactly how what I expect. And that's the idea behind a commit. Now, all of this game that we have done is purely on my laptop. You have no idea. You can get that idea as to what am I changing by doing what is called a synchronization between a remote. A Git has to have a remote for it to synchronize to or from. Right now in our Git, if you look at the remote in verbose mode, we have nothing. It's empty. Git remotes are empty, which means I need to have a Git remote connected in order for me to send my content over to you guys. Otherwise, you have no idea and you cannot synchronize, and I cannot synchronize with you. And so we need some kind of a central location with which we can do a remote connection. And that is how we will synchronize our Git repository among each other. And so that is our next idea. That next idea is to somehow take my folder called Badal and sync with some cloud service. This service is called GitHub. There are many such services, and many of them are free, including GitHub. GitHub is not completely free, but some of it is free. Now, in order for you to use GitHub, you need to have an account, which means you create one if you don't have one, like this, GitHub, and go there and create an account. And after you're done creating an account, you should give me your login name so that I can add you to the Cloud Genius group. And then we can share. This is like Facebook, literally like Facebook, where people are sharing these pictures among friends. And in GitHub, we are sharing code among friends or among team members. That's the idea. So GitHub is like Facebook, except for nerds or developers, I should say. And so what I would request you, each one of us, is to please prepare a GitHub login and paste it in the Slack chat so I can add you to the group. While you do that, I will take my repository that I have and send it over to GitHub. And this is something that you should watch. So this creation of a GitHub account can hold on. Just watch this one last step before we can probably hang up today. It's already beyond the hour. So what I want to do is ask you to create a GitHub account and then paste the username later in Slack chat. But for right now, watch this one step of me connecting my folder here with no remote connection. There is no remote right there. I have no remotes. So I will have to create a remote and hook it up with this Git repository, which is exactly what I want to do, for which I need to open GitHub right here and make sure that I am on to GitHub. So I'm basically going to GitHub, cannot type properly, github.com. There we go. And I'm going to log in, and in this GitHub location, okay, sign in. And once I sign in, I need to primarily find out my login name and password, which I never remember for some reason. So GitHub, what is my password? There we go. Copy, and in here, that's my login name and my password here, and sign in. And then authentication. Okay, this two-factor authentication, I have it everywhere apparently. I cannot get without it. So that's what we got. Okay, authentication, two-factor. Come on, bring it up. There we go. And GitHub is here. Copy the token, take it to this location, paste it, and sign in. Now we are connected to GitHub. Now here, what I'm essentially doing is go to my CloudGenius company account right there and creating a new repository. Click. And by the way, this repository is something that I would like to send this into the GitHub account. So I want to send from my laptop over to GitHub. So I'm going to name it Badal, same thing. And here, this is a public repository. We'll experiment with both scenarios. Right now, it is the public repository. And here, I am not initializing it with a README because the repository is already initialized. It is an existing repository that I'm importing into. So skip this step if you are importing an existing repository. And that is what I intend to do because I have the repository already. I want to import this one by connecting a Git remote to it and sending this content over to GitHub. And that is the reason why I do not want to initialize. And by the way, these are the steps. You don't have to do these steps. It's only one time you do these steps, but I'm just showing it to you so you're aware. And having done that part, I am not initializing this repository on GitHub because I have it already here. And having said, create, which gives me a handle. Now I have this handle back, which is an SSH handle or an HTTP handle. One of these two handles that I would suggest that you use the HTTP handle. I would suggest that you do not use SSH handle unless you're ready with your SSH key pair that you have to give to GitHub. Just like you did in Amazon's case, you went to your SSH folder, and apparently I am not in the right location. So you went to the SSH folder and you have the public key and private key. You have to give this public key over to GitHub. If you do that step, then you can use the SSH connection. Otherwise, you have to use a password-based authentication, which is available to you in the HTTP mode of connectivity. So that is the difference between this mode, which is a Git-based, SSH-based connection, and HTTP-based connection. Both methods are possible, but for the SSH one, you have to provide your IDRSA pub to GitHub. So I want to do that and show you the complex route, but the easier route is to just go HTTPS. To finish off, I need to go to my profile in settings and find out the SSH keys. And here I want to add a key, and I will give it a name called ID_RSA, and then paste the content of the ID_RSA right there, .pub. And we have the content. We just take it from here, copy it, and paste it right here. and then click the add key button. Now I have my key, this private key can be used to connect to GitHub without any need to type a password, which means I can use the SSH method, which means I can then go this section and copy the SSH URL and use that as my hold on, let me go there. Use that as my Git remote, which is currently blank. So the Git remote is blank, and this instruction is actually telling me to add a Git remote right there. Please add a Git remote called origin with that link. So I will need to do that. I'll basically take that command and bring it here and paste it. So what I'm doing is adding a new remote connection to GitHub in the Cloud Genius company for the Badal repository and call it the origin. That's the name, short name. This is the link. And that's the short name for the remote. And it is going to be added to this repository. So once I add, I will have a remote established. So I'm going to add this remote and then check my remotes. And I see that I have the remote connection for fetching and for pushing, for both. So I can fetch, let me show it to you again, clear, git remote. And I have two links, remote links, one for fetching, one for pushing. They're basically the same links going to the origin, which is this location. And that location currently is empty, but I want to now push. So I will take this command, push my changes, my content from this location over to the origin location. So this is where it will go. This origin means this address, which means this site right here. So as soon as I push, click, it says, do you know what you're talking about? Is this GitHub? I'll say yes. And so it goes and sends my content over to the GitHub location right there, which means I have the file called a.txt there showing up with a message that I have created this a.txt because Nilesh asked me to do so. Bingo, we got it. Now what? Now what we need to do is make sure that I tell my team members that, hey, team members, this is the location for the remote for the Git. Please use it in your laptops so that you can also contribute to the teamwork. And please go ahead and make use of this location in your machines to play around with and making sure that we succeed in our goal. Our goal happens to be, what is our goal? Is to create a folder with 26 files. And I just created a.txt. We have to create the rest of the files. And I would like you to do that. And there are deliberate things that I should clarify that who will do what. Right? I will have to make that assignment as a leader that, you know what, Alex, you do C and D, and I will do B. And Cal, you do the next two, which is E and F. Deepak, GH, Gautam, IJ, like that. So let me see the whole list. Hold on. So I hope you remember. I'll type the assignments in Slack chat so you don't have to remember these things. I'll do that part later. But for right now, what I am suggesting is to wrap up today's discussion is that we have created a new repository called Badal here that contains only one file right there, and with a commit message that I typed, and it shows up here, and it is a public repository right now, so you have access to it. And I will create a team and put you in the team and give you access to a private repository to play that scenario also, which should be quick. The build-up of Git is the most time-consuming and hard to understand part, which is to be able to clearly understand what are we really doing is keeping track of changes in some random folder. This, in our case, it's the Badal name. In that folder, we are creating these files, and we are going to be doing it distributed across the team in multiple locations, all the way from A through Z. And we are, as a team, going to construct this folder with this content using Git as a tool to manage the change. And that's the Uber scenario. That's what essentially we are using this as a change management tool across a team. It's a very trivial exercise. By the way, the project is like trivial. It takes me 10 seconds to finish this off. But that's not the point. The point is we want to do this with a very tiny example, but across a team of 13 people right now. And that's the goal. So we will do this exercise. In the meanwhile, please create a GitHub account, pass on a link, and if you feel comfortable with doing what I am suggesting, or at least hinting at what you should be doing, please go ahead. Send me a pull request. If you know what Git is, my request would be send me a pull request. That's what I'm asking you, essentially, right? So on GitHub, send me a pull request. If you know Git already, please do that. Send me a pull request with a change for 2 files that you can pick. Just take your pick. By the time if I type on Slack as to what do you want to add, if I don't do that before you finish this off pull request, take your pick and do whatever characters you feel like. I'll adjust for the rest. So if you know what Git is, send me a pull request. If you don't know what Git is, or if you don't know how to send a pull request, wait for the next opportunity. Got it?
Nilesh, I got a question.
Yes.
So the repository that's on GitHub side, so that's like a cloud service too, right?
Correct.
Okay. It's something that's accessible only through account, but it's multi-tenant.
It is. There's no such concept of tenancy, because that particular folder we have is owned by me. It is in my account. It's in the Cloud Genius account. So it is not multi-tenant.
So let's say if I okay, but it's public right now. Like
It is, yeah, it is public, but it doesn't mean you can write to it. It does not mean you can write. All it means you can read. Only I can write unless I give you permission, which I will do. But this segment of GitHub is totally owned by me. I pay for it.
Okay.
So does that give you a good enough idea to begin with? And once we do more exercises, and once you will also do this pull request business and Git merges and basically the collaboration steps, you will get clarity on what this Git thing is, because this is an essential tool in any kind of collaboration. It is not just for developers, by the way. Yes, developers love it, but it is not just for them. It is for everybody. It is for anybody who's collaborating with documents across a large distributed team. And that's where Git comes in handy, and we will make more use of it to understand it and then apply it. With that, any further questions for today before we hang up?
Oh, it sounds good. Thank you, Nilesh.
You're welcome, sir. Hey, was I recording, or what happened to the recording? Oh, it is being recorded. Good. Yeah, I was scared for a minute.
Yeah, the red dot's there.
Yeah, I could not see it for some reason, so I got scared. But yes, it is being recorded. So I'm going to pause the recording now. Thank you.